Everything happens for a reason. Whatever it is, good or bad, maybe it's not according to our own plans, but it happens for a reason. And all that happens because God wants you to become the best version of you.
Hello everyone, this is Mo and welcome to Unit 1 of our Python Wizards for Beginners course. In this unit, we are going to cover the basics of Python programming and get you up to speed with some essential skills that you will need to tackle more complex challenges later in this course. Our first lecture is an introduction to Python itself. We will cover what Python is, how it is used, and why it is such a popular programming language. We will also talk about the different versions of Python and which one we will be using in this course. By the end of this lecture, you will have a basic understanding of Python and be ready to dive into some hands-on coding exercises. In our second lecture, we will talk about the history of Python and who made it. The third lecture will talk about a step-by-step installation guide of Python and get to run your first code. Our first program is not Hello World, it's Hello Python Wizard. By the end of the fourth lecture, you will cover an understanding or you will develop an understanding of Python syntax and how to read and interpret it. In lecture number 5, 6, and 7, we will cover variables, data types in Python. We will talk about how to declare and assign values to variables, and we will explore the different data types that Python supports, such as integers, floating point numbers, strings, and more. We will also cover operators and expressions in Python. We will talk about how to use arithmetic operators like addition, subtraction, multiplication, and division, as well as comparison operators like less than or greater than and equal to. We will also cover logical operators like and, or, and not, and show you how to use them to create complex expressions in your code. By the end of this lecture, you will be able to write Python code that can perform calculations and make decisions based on input data. Hello everyone, this is Mo again and welcome to lecture 1 of our Python Wizard for Beginners course. In this lecture, we will cover what Python is, who made it, why it is such a popular programming language, what is it used for, and what applications made with Python. And by the end of this lecture, you will have a basic understanding of Python and be ready to move forward. So, what is Python? It is a programming language that is gaining popularity in the world of technology. Python is a powerful language that has become a preferred choice for developers and programmers for a number of reasons. Firstly, Python is a programming language that can do anything. Yes, it can do anything. It is a general purpose language that can be used to develop a wide range of applications such as web applications, games, data analysis, and machine learning. The language is designed to be easy to read and write, which makes it an excellent choice for both beginners and experts. Secondly, Python is free and open source. This means that anyone can download and use the language without having to pay a license fee. Additionally, the source code is available for anyone to access and modify. This openness has led to a vast community of developers who collaborate and contribute to the language's development. Thirdly, Python is interpreted. This means that the code is executed directly by the computer without the need of compilation. Interpreted languages like Python are usually easier to debug and test because developers can see the results of their code as they write it. And you will see how we can do that in later lectures. This allows for a quicker development cycle and can lead to more efficient and effective coding. Lastly, Python is interactive. What does that mean? This means that developers can run code and see the results immediately. This is especially useful when working with data analysis or machine learning, as developers can quickly test and modify code to see the impact on results. Python was first released in 1991 by Guido van Rossum, and the language the language was named after the Monty Python comedy group, and the logo featured a python snake. If you are new to programming and want to learn a language that is easy to install, clean, and easy to understand, then Python is the perfect choice for you. Python has a simple syntax that makes it easy to learn and use. Python is known for its excellent error handling, which means that it is easy to debug your code. Furthermore, the built-in debugger is incredibly helpful for developers. Python is a cross-platform language, which means that it can be used on various platforms, including Windows, Mac OS, and Linux. It is also expressive, which means that you can write code that is easy to read and understand. Another benefit of Python is its support for object-oriented programming, OOP. OOP is a programming paradigm that focuses on objects and their interactions, which makes it easy to create complex programs. Python is an integrated language that supports modules and packages, which makes it easy to reuse code. Python has a large set of libraries and plugins, which means that developers can easily find the tools they need to complete their projects. Python's garbage collection feature makes it easy to manage memory, which means that you can focus on writing code instead of worrying about memory allocation. Python is a multi-purpose language, which means that it can be used for a wide range of applications. The Python community is vibrant, supportive, and helpful, which makes it easy to get started with Python and keep learning. Python is growing fast, and with basic knowledge, you can switch careers and become a successful Python developer. Python is an excellent choice for developing machine learning application because its support for machine learning is exceptional. Python is growing fast, and with the right knowledge, you can become a successful machine learning developer. Python is an excellent choice for developing web applications because it has a large set of libraries and plugins, which means that developers can quickly find the tools they need to develop web applications. Python is a multi-purpose nature language, which makes it an excellent choice for developing web applications. Python's web frameworks, such as Django and Flask, provide developers with powerful tools to create web applications quickly and efficiently. Python's ease of use and readability makes it an excellent choice for developing web applications, whether you are a beginner or experienced developer. So, whether you are developing a simple website or a complex web application, Python is a perfect choice for web development. Python has become a go-to language for web developers thanks to its simplicity and versatility. Two of the most common Python web frameworks are Django and Flask. Django is a high-level framework that encourages rapid development and clean, pragmatic design, while Flask is a micro web framework that is easy to use and flexible. Both frameworks provide a powerful set of tools for building web applications that can handle everything from simple blogs to complex e-commerce sites. With Python and these frameworks, web development has never been easier. Python is a great language for game development because it is easy to learn and has a large community of developers. One of the most popular Python game development frameworks is Pygame. Pygame provides a set of tools and libraries that make it easy to create 2D games. It has support for graphics, sound, and input handling, making it a great choice for creating games that are both fun and engaging. Python is a great language for desktop application development because it is easy to learn and has a large community of developers. Two of the most popular Python desktop application development frameworks are PyGUI and Tkinter. PyGUI is a cross-platform GUI toolkit that provides a set of tools and libraries for creating desktop applications, while Tkinter is a standard Python library for creating graphical user interfaces. Both frameworks provide a powerful set of tools for creating desktop applications that are both simple and powerful. Python is a great language for hacking purpose because it is easy to learn and has a huge community of developers. Python provides a set of tools and libraries that makes it easy to automate tasks, manipulating data, and create custom tools. With Python, ethical hackers or white hat can automate tasks like reconnaissance, brute force attacks, and information gathering. Python is also provide a powerful set of tools for analyzing data and finding vulnerabilities. Python is a great language for machine learning and data science because it provides a powerful set of tools and libraries. Two of the most popular Python libraries for machine learning and data science are NumPy and Pandas. NumPy is a library for numerical computing, and Pandas is a library for data analysis. Both libraries provide a powerful set of tools for working with large data sets, performing complex mathematical calculations, and creating visualizations. Python is a great language for artificial intelligence and robotics because it provides a set of tools and libraries that make it easy to create intelligent systems and control robots. One of the most popular Python libraries for artificial intelligence and robotics is TensorFlow, which is an open source software library for data flow and differentiable programming across a range of tasks. It's commonly used for developing machine learning models, including neural networks, and for deploying them into production. Another popular library is OpenCV, which is a library of programming functions mainly aimed at real-time computer vision. Python has also been used in the field of robotics, with the Mars rover being a notable example. Python was used to program the rover's onboard computer, which controls its movement, data collection, and analysis. Python's ease of use and powerful libraries made it an ideal choice for this application. With Python's extensive libraries and tools, the possibilities for artificial intelligence and robotics are endless. Who knows what amazing things we can accomplish with Python in the future? Maybe we will even have robots on Mars controlled by Python code. Who knows? Python is a great language for automation because it provides a set of tools and libraries that make it easy to automate tasks, including repetitive or time consuming tasks. Python can be used to automate tasks in a variety of areas, such as web scraping, data analysis, testing, and more. For example, Python can be used to automate the process of extracting data from websites, which is known as web scraping. Python provides a powerful libraries like Beautiful Soup and Scrappy, which makes it easy to extract data from HTML and XML documents. Python can also be used to automate testing processes, ensuring that code runs smoothly and accurately. Python provides libraries like unit-test and by-test for writing and executing tests, making it easy to automate testing processes. With Python and its extensive libraries and tools, automation has never been easier. Python can be used to automate a wide range of tasks, making it a valuable tool for developers, data scientists, and anyone looking to streamline their workflow. Python is a great language for web scraping, as we mentioned earlier. Python is a great language for Android games development because it is easy to learn and has a large community of developers. One of the most popular Python libraries for Android games development is Kiwi. Kiwi is a cross-platform Python framework for the development of applications that make use of innovative user interfaces such as multi-touch apps. It supports a wide range of platforms, including Android, iOS, Windows, and Mac. Kiwi provides a set of tools and libraries for creating 2D and 3D games that are both fun and engaging. With Python and Kiwi, Android game development has been very easy. Kiwi provides a powerful set of tools and libraries for creating games that can handle everything from simple puzzles to complex action games. Whether you are a seasoned game developer or just starting out, Python and Kiwi can help you create amazing games for the Android platform. In addition to Kiwi, there are other Python libraries that can be used for Android game development, such as Pygame and Panda 3D. Pygame is a set of Python modules designed for writing video games, while Panda 3D is a game engine that provides a set of tools and libraries for creating 3D games. With Python and its extensive libraries and tools, the possibilities for Android game development are endless. Whether you are looking to create a simple puzzle game or a complex action game, Python can help you bring your ideas to life on the Android platform. Instagram, Spotify, Dropbox, Uber, and many more are using Python, and Python was a major programming language used to create them. Yeah, that's our conclusion. So, Python is a powerful programming language that has many benefits. It's a language that can do anything, free and open source, interpreted and interactive. As technology continues to evolve, Python is an excellent learning language to learn and use for a wide range of applications. Python's various uses, including web development, game development, desktop apps, hacking, machine learning, data science, AI, robotics, automation, web scraping, and Android game development. Python's versatility and ease of use makes it a valuable tool for developers in a wide range of fields. So that's it for lecture one. I hope you are feeling excited about Python. Remember to take your time with the assignments after each lecture and ask questions if anything isn't clear. I will see you in the next lecture. So that's it for lecture 1. I hope you are feeling excited to dig deep into Python programming, and I will see you in the next lecture to learn more about how to install Python and run our first code. See you. Hello, Python wizards. This is Mo again, and today I will be guiding you through the process of installing Python and running your first program. This presentation is aimed at beginners who are new to Python and want to get started with their programming journey. By the end of this session, you will have Python up and running on your machine and be able to write and execute your first Python program. So let's get started. Previously, we discussed that Python has become one of the most popular programming language, known for its simplicity and versatility. It is widely used in various domains, including web development, data analysis, artificial intelligence, and more. Whether you are a student, a professional, or simply curious about coding, learning Python is a valuable asset. In today's presentation, we will cover the step-by-step process for installing Python, setting up the Visual Studio Code (VS Code) editor, and running your first Python program. To begin our journey, let's start by installing Visual Studio Code, a powerful and user-friendly code editor that provides excellent support for Python programming. VS Code is free and available for Windows, Mac, and Linux. All links for required resources are attached to this lecture. Here is how you can get it. Visit the official Visual Studio Code website at code.visualstudio.com. Download the installer package for your operating system. Run the installer and follow the on-screen instructions to complete the installation. Once installed, open VS Code, as you can see in the picture here. Now that we have our code editor ready, let's move on to installing Python itself. Python offers different versions, but we will be focusing on Python 3, as it is the latest and recommended version. Here is how you can install Python. Visit the official Python website at python.org, click on the Downloads tab, and select the Python 3x version appropriate for your operating system. Run the installer and follow the on-screen instruction. And make sure to check the Add Python to Path option during the installation process. To enhance our Python development experience in VS Code, we will install the Python extension. This extension provides features such as code auto-completion, linting, and debugging capabilities. Here is how you can install it. Open VS Code, click on the extensions icon in the sidebar or press Ctrl-Shift-X to open the extensions view. Search for Python in the search bar. Look for the official Python extension developed by Microsoft and click on the install button. Once installed, you may need to restart your VS Code. Congratulations! We now have everything set up to write and execute our first Python program. Let's start with assemble Hello Python Wizards program, which is a traditional way of beginning your coding journey. Follow along with me. Open VS Code, click on File and then New File to create a new empty file. Save the file with a hello.py extension, for example, hello.py. Type the following code into the editor. Print hello Python wizards, as you can see in the screen. We will discuss what does everything means in later lectures. Now let's execute our program. There are two ways to run a Python program in VS Code. One, using the run button in the upper right hand side. Click on the Run button in the VS Code sidebar or press Ctrl plus F5. If prompted, select Python as the environment to run the program. You should see the output Hello Python Wizards displayed in the Terminal Below tab at the bottom of the VS Code window. The second method, by using the integrated terminal at the bottom of the screen. Open the integrated terminal in VS Code by clicking on View and selecting Terminal, or by pressing Ctrl Shift plus single quote, or you can tap on Terminal and select New Terminal. Ensure that the terminal is pointing to the directory where your Python file is saved. Type the command python hello.py in the terminal and press enter. You should see the output hello Python wizards displayed in the terminal. Both methods are okay to run any Python code. You will find a practice code for the same hello.py after you complete this lecture. Make sure you practice on it. Congratulations! You have successfully installed Python, set up VS Code, and executed your first Python program. This is just the beginning of your Python journey. Python offers a vast ecosystem of libraries and frameworks that you can explore to build exciting applications. Remember, practice makes perfect. Keep coding, experiment with different programs, and embrace the joy of learning. If you encounter any issues, don't hesitate to seek help from the Python community, or just hit any comment below in the course webpage, or refer to the communication and resources available online, and I will be guiding you through your learning journey. All the links for required resources are attached to this lecture. Make sure you visit them and become familiar with all the resources. Welcome again, Python withers, to today's lecture on understanding Python syntax. Python is a popular and versatile programming language known for its readability and simplicity. What does it mean? It means that it is easy to understand when you read the command line, just as if you are reading an English sentence. It is simple as every word in the command line indicates literally, it indicates literally what it means, like what we had in the previous lectures, print hello Python wizards. So the command doing a print function to the phrase hello Python wizards. It's so simple. Command line here means the order that I am giving to Python to execute. For example, as I said, print hello Python wizards, similar to what we did in the previous lectures. In this lecture, we will provide the fundamental components of Python syntax, including variables, data types, assigning values to variables, and working with strings, integers, and floating numbers, etc. By the end of this lecture, you will have a solid foundation in understanding Python syntax and be well equipped to write your own Python programs. So let's get started. Python syntax refers to the set of rules and conventions that dictate how Python code should be written and structured. It defines the correct arrangement and usage of keywords, symbols, and statements in the Python programming language. Just like any other language, in order to learn English, you need to learn its grammar, punctuation, and vocabulary. Then learn how to structure your sentence. Python syntax includes guidelines for defining variables, declaring functions, creating control structures like loops and conditional statements, working with data types, and using operators. It also outlines the proper indentation and formatting rules that ensures code readability and maintainability. Here are a few key aspects of Python syntax. Indentation. Python uses indentation to define code blocks, such as in control structures and functions. Consistent indentation using spaces or tabs is crucial for code readability and is typically done with 4 spaces. Variables. Variables in Python are created by assigning a value to a name. There is no need to explicitly declare the variable type. Variable names should follow certain conventions, such as starting with a letter or an underscore. Data types. Python supports various data types such as integers, floats, strings, booleans, lists, tuples, dictionaries, and more. Each data type has its own syntax for declaration and manipulation, and we will learn all of that in the future lectures. Operators. Python provides a range of operators for arithmetic, comparison, logical operations, and more. These operators are used to perform specific tasks on variables and values. Control structures is another syntax for Python language. Python offers conditional statements if, elif, else for decision making and control flow. Looping structures for and while allow repetitive execution of code. Functions. Functions in Python are defined using the DEF or def, or its abbreviation for define keyword, followed by the function name, then parentheses, and a colon. The function body is intended, and arguments can be passed within the parentheses. Comments. Python allows the use of comments to add explanatory notes within the code. Comments are preceded by the hash symbol and are ignored by the interpreter. Understanding and adhering to Python's syntax rules is crucial for writing correct and functional Python programs. It ensures that the code is consistent, readable, and interpretable by the Python interpreter. So, let's start with exploring the concept of variables and assignment in Python, along with some important naming conventions. Variables are an essential part of any programming language, including Python. They are like containers that store data. In Python, unlike some other programming languages, Python is dynamically typed. You don't need to explicitly declare the variable type, and you can create a variable by just using an assignment operator, which is equal sign. The equal sign operator assigns the value on the right hand side to the variable on the left hand side. Let me show you an example. In this example, we have created four variables: name, age, temperature, and is underscore student. We assign different values to each variable using the equal sign operator. We assigned a string to Muhammad al-Sharqawi to name, assigned integer number 25 to age, which is not my real age, assigned float number 36.5 to temperature, and assigned true to is student. Notice that we didn't have to specify the variable type explicitly. Python automatically determines the appropriate data type based on the assigned value. This means Python will make name as a string, age as integer, temperature as float, and is underscore student as Boolean variable. We said before, Boolean variables are true or false. By the way, I use student, but I'm not student anymore. But we all learn. We keep learning. So after all, we are all students. You can name the variables as x and y or whatever, as in this example, but it may confuse you later on if the code is too long. It's much better that the variable name be indicative or descriptive of the value that is assigned to the variable. There is a workaround by using comments to describe what the variable is, though we will see that in our practice questions at the end of this lecture. But again, make sure that your variables are indicative or descriptive. Variables in Python are mutable. What does that mean? It means that their values can be updated at any point of the code. Let's see an example. In this example, in this updated example, we reassigned new values to the age, temperature, and is student variables. We changed the age from 25 to 26, still not my age. The temperature from 36.5 to 37.2, and the is student from true to false. And I can do that at any time throughout the programming process. This flexibility allows us to modify variables as our program progresses, unlike other languages where you have to compile, interpret, and execute the program all over again to update these variables. Another example, we have a variable called count. It was initially assigned the value of 5. We then updated the count variable by adding 1 to its current value. The new value would be 6, replaces the old value of 5. I can place the count equal count plus 1 at any line or place in the code to update the variable. So easy. Now that we understand the basics of variables and assignment, let's talk about naming conventions for variables. Following proper naming conventions is important for code readability and maintainability. When naming variables, it is essential to choose descriptive and meaningful names. This helps convey the purpose of the variable and makes the code more understandable. Didn't we say that Python is clear, concise, and readable and all of that sweet talk? Yeah, right? So we need to do that in our coding. Variable names should start with a letter or an underscore. They cannot begin with a number. Let's take a look. In this example, we have three variables. First underscore name, underscore last underscore name, and age, all caps letter. Notice that variable names should start with a letter or an underscore. It is always a good practice to use descriptive and meaningful names to make your code more readable and understandable. Do you see how many times I repeat that phrase? So you make sure of that. Additionally, avoid using reserved keywords as variable names. What does that mean? Okay. Reserved keywords are special words that Python uses for specific purposes. Like what? Do you remember the print function that we talked about earlier? Yes? Okay, good. So it is just like the print functions. And if, for, while, and if, etc. Let's see an example. In order to know all
In
the
this
reserved
updated
keywords
example,
in
we
Python,
assign the
you can
value
follow these
hello
steps to a variable named
print.
open, which is a reserved keyword in Python. This is not recommended as it can lead to errors and confusion later on in your code. In order to know all the reserved keywords in Python, you can follow these steps. Open your Python interpreter or an integrated development environment IDE like the VS Code we installed in the previous lecture, or any other IDE like Spider or anyone that provides a Python console. Type help, open parentheses, double quotes, keywords, double quotes, close the parentheses again in the Python console and press enter. This help function will display information about the keywords in Python. It will show a list of the reserved keywords used by the Python language. In Python 3.6, there are 33 reserved keywords. Here is an example of how it would look like in the Python console. After executing the above code, the Python console will display a list of all the reserved keywords. These keywords are essential parts of the Python language and have specific meanings and functionalities. You can see this list anytime by typing help keywords to the Python interpreter. Reserved words are case sensitive and must be used exactly as shown. They are all entirely lowercase except for false, none, and true with the first letter in capital. You can see all of this in this picture in the screen. All of these reserved keywords here in this picture. And that wraps up our discussion on variables and assignment in Python for the beginners level. Remember, variables are used to store data and you can assign values. After we became familiar with variables and assignment, let's start talking about data types. Python supports various data types, each with its own characteristics and operations. Let's take a look at some commonly used data types. First, we have integers. Integers are whole numbers without any decimal points. They can be positive or negative, +1, -10, any number, whole number without decimal. Second, we have floats. Floats represent numbers with decimal points. They can be used for handling fractional values like 1.5, 10.68, -1.765, -100.00002356, whatever. Strings. Strings are sequence of characters enclosed in single or double quotes. They are used for representing textual data. Booleans. Booleans represents the truth value of an expression. They can have two possible values, either true or false. Lists. Lists are ordered collections of items enclosed in square brackets. They can contain elements of different data types. So they can contain integers, floats, strings, booleans, mix of data types inside this list. Tuples. Tuples are similar to lists but are immutable. What is that? It's the meaning of immutable is they cannot be modified after creation. They are enclosed in parentheses, not square brackets. Next, we have dictionaries. Dictionaries are a key value pairs enclosed in curly braces. They allow you to store and retrieve data using unique keys. Each data type has its own characteristics and operations. To determine the data type of a variable, you can use the type function. We have a function called type to check the type of each variable. It returns the data type of the variable. For example, if we write type 5, it will return the class of that 5, which is int, means integer. So the type of 5 as a data is integer. Another topic we need to understand is operators. Python provides a wide range of operators that allow us to perform different operations. Let's explore some of them. We have arithmetic operators. These operators like plus, minus, asterisk, front slash, percent, front slash, asterisk, asterisk. These has a meanings, has a mathematical operations like addition, subtraction, multiplication, division, modulus, floor division, and exponentiation, respectively. Next, we have comparison operators. The comparison operators like equal, not equal, greater than, less than, greater than or equal, less than or equal, which compares values and return Boolean results. They are used to evaluate conditions or make comparison between variables. Logical operators. Logical operators like and, or, not. They are used to combine Boolean values and perform logical operations. And returns true if both operands are true. Or returns true if at least one operand is true. And not negates the Boolean value. These operators are fundamental in Python and help us perform a wide range of operations and comparisons within our programs. That's all for data types and operators in Python. Remember, understanding these concepts is crucial for manipulating data and making logical decisions in your program. It will help you a lot in our practice examples in the following lectures. Hello, everyone, and welcome again with our hands-on training or hands-on practice exercises for unit number 1. So let's start. This is a hashtag, as we said, it's a comment, and we'll talk about it later. But just for the decoration of this lecture, we'll just make some comments about Unit 1 Practice Exercise. Yes. And make another line like this. And let's start. So let's start and stay alert and practice with me going forward. Starting with Python syntax. It's a very thing, Python syntax. Okay, how to write Python syntax? We can write Python syntax in two forms. The first one in multiple lines, like this. If we say print hello Python wizards, then again in another line, print my name is Mohammed. See, do you remember what I said about reserved keywords? You need to write the keyword as exactly as it is. Here I wrote print in the first line with P small, and I wrote print in the second line with P capital, and the beautiful VS Code marked it as incorrect. I need to change the B from capital to small, and the error will disappear. Okay, so this is the first method to write a Python syntax. If we go to run it here from this little arrow, let's save the file first. Let's save it. Unit 1 practice.py and save, and voila. Hello Python wizards, my name is Mohammed. Okay, so let's see the other type of the second method to write the Python syntax. We can get these two lines. Okay, sorry about that. Control C, Control V, and on the first line we will add semicolon and write the second line right after the semicolon and say run. It will say the same thing, same result. Hello, Python wizards. My name is Mohammed. So it's either to write it in multiple lines like the first method, or in one line with a semicolon in between the commands in the second method. Both of them will have the same output. Okay? So just making it more concise and fancy and that stuff. Right? Let's move on to our next topic today, which is indentation. Indentation. Okay. And as we said in our literature in the previous lecture, we talked about indentation. And we said that indentation is useful to understand the multiple lines are a block of code. The block of code needs to have the same indentation in order to function properly. Let's see the previous example. They are in the same indentation. Let's take a copy of this and put them here and talk about it. See here, they are both lines start from the same point, same distance. They have the same indentation. Okay. The block of code needs to have the same indentation in order to function properly. So if I added one indentation here, for example, I just hit the space here. So you see that there is a red zigzag here and red zigzag here, red line. This is an error. That is an error. So it doesn't matter. 1, 2, 3, 4 indent. It needs to be in the same indentation. So in order to fix that, it's either to remove this indentation or to add the same indentation in the previous block here. But as you can see, because we have a continuous block of code from the previous ones, we have here an error for this. If you come here and removed all of these, let's make it like that, and you will see the error. Sorry, here. Oh, come on. Oh, disappeared. Okay, so we say that indentation is useful to understand that the multiple lines are block of code. Let's write it here so you keep it in your memory and it can be a reference for you later on. And the block of code needs to have the same indentation. Moving on, let's explore comments. Comments are lines in our code, as you can see here with the hashtag. Um, these are not executed. They exist solely for humans to read and understand. We use comments to provide explanation, document our code, or temporarily disable certain lines, like what I did in the print functions earlier. In Python, comments start with the hash symbol, and we can see here a lot of examples. Let's bring them here, like you see. So in this code, we have multiple comments that provide information about the file and its purpose. And comments ways are great ways to make your code more understandable for yourself and others who will read the code after you. Uh, so and yeah. Lastly, I want to clarify something about multiple lines of comments. Multiple lines of comments. How to do multiple lines of comments. This is a method that is misconceived as a comment, multiple line comment. It actually can be used as a comment, but it is not a comment. It's A multi-line string that is not assigned to a variable. Okay, so it is a multi-line string that is not assigned to a variable. So consequently, it doesn't affect the execution of the code as we can see here in the example. Let's run this code and see if we will notice anything in the console or not. Run here. The only thing we have is hello Python withers. My name is Mohammed. And we don't see this. This is not multiple line comments. Now we covered some basic Python syntax. Let's dive into the fascinating world of data types. Let's remove all of this and I will attach the complete file for you later. Let's talk about data types. Data types, we use the type function to show the type of the data as we talked about it earlier. All data in Python is object. We will use a print function to print out the class of the data returned by the type function. Okay, so to determine the type of data, we can use the type function. This function helps us understand the nature of the data we are dealing with. Let's explore some common data types and see how they work and how we use type and print functions to know the data types in Python. First, we have the int data type is integer like this, uh, which represents integers, the whole numbers without decimal points. So we have print type 1. I wrote here the outcome will be integer. So let's see if that is true or false. Let's hit run and see here the class is integer. That is correct. Another example can be like if we write down 1,000 or -10, all of them will be integer. All right, all right. Moving on, let's talk about the float number. We have the float data type, which represents the floating point numbers with decimal points. Let's see these examples. If we have Brent type 1.5 and Brent type -10.99999. If I hit run, it will say class float. Okay, so similarly, we have another type of strings, sprint, hello, Brent type hello Python withers, which will be as str string, and we have many examples for list tuples. Let's see lists and tuples. If we have some examples here, print type 1, 2, 3, 4, 5. This is a list of numbers, and print type A, B, C, D, E. It's a list of strings, and I have here a tuple uh, consisting of numbers, and a tuple consisting of strings. Hit run. It will show you here the first two are lists, the second two are tuples. Okay, so I said some notes about lists and tuples before. Do you remember them? I brought them here for you to remember. Let's take a look. We said that. Who remembers before I say, huh? Okay. We said that lists and tuples are a bit similar with some differences that we will know later in advanced topics. For now we say that I can reassign or change the variables at any point throughout the code. Yes for lists and no for tuple. List can be changed or modified after its creation according to needs, and tuples can be changed or modified after its creation. For more information about that, you can visit programmers.com/python programming list versus tuples. You'll have a very long discussion about the similarities and differences between lists and tuples. We have the dict data type. Dict is an acronym for dictionary. As you can see here in this example, Bren type 1 colon 1, 2 colon 2, 3 colon 3. Dictionaries, they store pairs of data, pairs of values, sorry, and are enclosed in curly brackets. Pairs of values like these, the 1 colon 1 in numbers, 2 string and its pair is 2 in numbers, 3 and the meaning of it 3 in numbers. So it stores the data in pairs. Like here, the class is int. Similarly, I have a Boolean data type 2 equals sign 2, and see if the two sides are equal or not. It's a Boolean type, Bool. So did you notice the easiness of the Python language? Just as if you are writing an English sentence. Now we will move to another essential concept in programming, which is variables. Let's remove these from here and write down variables. Okay, variables are like containers that hold data and allow us to store and manipulate values like we talked earlier. In Python, creating a variable is as simple as following a few rules and conventions. To create a variable, we use the syntax. We use the syntax variable name, assignment operator, which is the equal sign, and the value. The assignment operator, represented by the equal sign, assigns the value on the right to the variable on the left. Okay? Let's see some examples. I have prepared for you 3 examples here. Name equals Muhammad El Sharqawi. My name equals Muhammad El Sharqawi. My underscore name equal Muhammad El Sharqawi. So these are different variations of how to name your variable. So the first one is our normal naming of the variable, which is only one word. The second line, my name with the N capital, this is a camel case naming, which is 2 words together with the second one starting with a capital letter. And the last line, my underscore name, this is a snake case, which is 2 words together with an underscore between them. In these examples, we create variables named name, my name, and my underscore name, and assign them the value Muhammad al Sharqawi. If you run that, it will show you all of because I did not print them, it didn't show anything here in the console. But these are 3 variables. Remember that variables are case sensitive, so name all small letters is not like name with capital N or name with all caps, would be all considered different variables. Now let's talk about naming conventions and rules of variables. Variables, as I wrote here, variables can start with A to Z small or A to Z capital or underscore. Variable names cannot start with numbers or special characters. Okay? Variable names can include numbers or underscore, but no other special characters. Variable names cannot include special characters like add, dollar sign, percent, etc. Variable names are case sensitive, so my variable with a V capital and my variable with V small would be considered different variables. It is important to note that you cannot use a variable before assigning a value to it. There are reserved names or words that I can't use, such as print and type, as we mentioned in our lecture. Finally, let's discuss about the escape sequences. And what are escape sequences? Let's remove these. Delete escape sequences. Here is escape sequences. Escape sequences are special characters that allow us to include characters that are not easy to type directly. Here are some common used escape characters. Backslash B, which is a backspace, it removes the character before it. Backslash new line, this escape new line continues the line of code on the next line. Backslash, it's escape backslash. It prints a backslash character. Backslash single quote, it escapes single quotes. It prints a single quote character. What does this mean, escape single quote? Yeah, it means it it ignores the effect of the single quote. We learned that single quote and double quote are used to identify a string, to make a string variable or a string object. So the backslash before the double quote or single quote, it avoids the effect of the single quote or double quote. So similarly, we just say that backslash double quotes, this escapes the double quote and prints a double quote character. Backslash n, that is a line feed which creates a new line. Backslash r, it's a carriage return, and that replaces the characters before it with characters after it. Like this. If you said A, B, C, D, backslash R, 1, 2, it will replace 1 C, D with 1, 2. So the output will be A, B, 1, 2. Okay? Last thing is backslash T, which is a horizontal tab that inserts a horizontal tab space. I made lots of examples for you here about all of that. I will not spend much time on it because it is so easy and can be understood by yourself. But anyway, we will go through them one by one. Backspace. If you say print hello backspace B Python wizards, that will remove the O from hello. Escape new line, it makes plus backslash, it prints every word in a line, in a separate line. No, sorry, it will escape the lines and prints all of these in one line. Escape backslash, here if I want to print a backslash. So first backslash will ignore the effect of the second backslash. Escape single quote, it will print a single quote. Escape double quote, it will print double quote. Line feed, and so on. Let's run and see the result. Here. Hello, it's removed the O from Hello, Python wizards. Remove the O. Second one, it printed all words in the same line. The second one, it wrote a backslash. The fourth one, it printed single quote. Next, it printed double quotes. And next, what was that? Line, line feed. Yeah, line feed. And the second one, second line here. And, and cartridge return replaced, replaced 6 by F. And the last one is the horizontal tab. It added tab between the words here, between hello and Python, and between Python and wizard. All right. Okay. It's let's move on. What is the next topic for us today? Yeah. Let's see. Yes, it's concatenation. Our next type is concatenation. Concatenation. How to connect two strings or more together with a plus sign. So, string concatenation is the process of combining two or more strings together. In Python, we can concatenate strings using the plus sign. This allows us to create longer strings by joining smaller strings. What all of that is about. Let's take a look about this example. I have x equals I love and y equals my family. As you see here, I used print function to print the outcome of concatenating x and y, combining these two variables together. And I used double quotes to indicate that this type of variable is string. All right, let's print x plus double quote space double quote plus y. The space here is just for grammatical formatting. Run. Here it is. I love my family. It's all in one line. I combined X and Y and printed them in one line. Note that in this example we have two variables, X and Y, which store the strings I love and my family, respectively. By using the plus sign and surrounding the strings with double quote, we can concatenate them together. The output will be I love my family as you see now. And notice that we add a space in between the two strings to ensure readability, as I said. We can also concatenate multiple strings by chaining them together. How is that? Like this example. I have a variable A, it's a multi-line string, first, second, third, and I have B, which another multi-line string, A, B, and C. Now I want to print A plus B. Let's run this code. Here we see first, second, third, A, B, C. We learned here that the backslash escapes the new line. So it is as if they are all in one line, not multiple lines. And it shows first, second, third, A, B, C. Okay. And any comments? Understood. So again, the backslash is used for line continuation, allowing us to write the strings on multiple lines for better readability. By concatenating A and B together with a space in between, we get the output first, second, third, ABC, as you can see in the console. It's important to note that you cannot directly concatenate a string with a number. Concatenation is between strings and strings. You cannot concatenate a string with a number. Python requires consistent data types when concatenating. If we write, for example, let's take that example, print and to always show you how to see what you do with a function, which is a good thing. Hi plus 1 and run. See here, it shows an error, type error. Type error can only concatenate string, not integer, to string. Wow, that's a beautiful language. Even the error message clarifies itself. It's a very clear way. If you want to combine a string with a number, you can convert the number to a string first. Let's use the str function to convert the number 1 to a string, then concatenate them. Now, if we run the code, it will say hi 1 because no more error here. It changed the number from an integer value to a string value. Then we made a concatenation between a string and a string. Now I hope it is clear. Let's move on to another topic, which is strings. Okay, strings are a fundamental data type in Python used to represent text. In Python, you can define strings using either single quotes or double quotes. Let's explore some examples. Here we have two variables, string 1 and string 2, which store strings. The first string is defined using single quotes, while the second string is defined using double quotes. Both strings will be printed as expected. Okay, let's print. It is Here it is printed. This is single quote, this is double quote. Okay, okay. Sometimes we may need to include single quotes within a string defined with single quotes or double quotes within a string defined with double quotes. What is that? Okay, let's take an example. To achieve this, you can use the opposite type of quote inside the string or escape the inner quotes with a backslash, like in this example. In this example, we define two strings, string 3 and string 4. This is single quote, and I used double quote inside the single quotes, and this is double quotes, and I use single quotes inside the double quotes. So the inner quotes are treated as part of the string and will be printed correctly. Let's print here. Oh, sorry. I I did it wrong. I should be here single and here double. Thanks for paying attention. Okay, double, double, single. Print. Yes, here is it. This single quote, it printed a single quote, and this is a double quote, it printed a double quotes. Okay, okay. I need now to do something. What is it? I need to print strings with multiple lines. If I want to do that, I can use the triple quotes like I used for when I said this is not a multiple line comment. I can use triple quotes, either triple double quotes or triple single quotes to make strings with multiple lines. Okay? Triple quotes allow you to include line breaks and special characters within the string without the need for escape sequences like in string 5 and 6 that you can see here. String 5 and 6. One. First, second, test. Okay. I have three single quotes, three single quotes. See, the editor is very beautiful. When you mark a triple quote here, it automatically uh, mark the other triple quote. So you make sure that your command is correct, doesn't miss anything. So triple quotes allow you to include line breaks, as I said, and special characters within the string without the need for escape sequences like in string 5 and 6. In this example, we have two multi-line strings, string 5 and string 6, defined using triple quotes. The strings can span multiple lines, and any special characters or quotes within them are treated as part of the string. Let's run this and it show you here. So, here, where is it? Yeah. Okay. All right. Now, who loves math. I love math. Math is very beautiful. And you should love math too. Let's talk about arithmetic operators such as addition, subtraction, multiplication, division, modulus, exponent, and floor division. Let's talk about each one. The addition operator is used to add two numbers together. The subtraction operator is used to subtract one number from another. The multiplication operator is used to multiply two numbers together. The division operator is used to divide one number by another. By default, it returns a floating point result. The modulus operator returns the remainder of the division operation. The floor division operator returns the result of the division, rounding down to the nearest whole number. And the exponent operator is used to raise a number to a power. I have prepared some examples for you to see and match the results as of what I came up with. Here are the examples. Here we go. Let's run and match our results. Let's go to addition. Where is addition? Here, the first one. Print 1 plus 3 equals 4. Brent minus 2 plus 2 minus 1 plus 2 equals 1. Brent 1.11 plus 2.66 equals 3.77. Let's see about, for example, here is modulus division. Brent 8 modulus 2, it is 0. 8 divided by 2 is 4, and there is no remainder of the division, while Brent 9 modulus 2 is 1. If you divide 9 by 2, it will give you 4 complete numbers, and the remainder is 1 half. Okay? 20 modulus 5 is 0, and so on. You can play with Python and solve any mathematical equation as if it is your calculator. So have fun reviewing all these numbers. Okay, we talked about Boolean operators, and we said that we have and, or, and not, and it is similarly like we gave some examples about the arithmetic operators. Here is some other examples about Boolean operators. So I created three variables: age, which equal 36, country, which is planet Earth, and rank is 10. So if I said Brent age greater than 21 and country equals planet Earth and rank greater than 0, it will show you a true Answer: because age is 36, 36 is greater than 21, and country equals planet Earth, and rank is greater than 0. 10 is greater than 0. And all conditions are true. So it will show you true. While in the second example, where we have print age greater than 21 and country equals planet Mars, not Earth anymore, planet Mars, and rank is greater than 0, only one condition here is incorrect. So it will make all the statement false or incorrect. So it shows here false. Similarly, if I print age greater than 21, it will show you true. Print not age greater than 21, it will show you false because the age is already greater than 21. Okay? Easy, easy peasy lemon squeezy. The third type of operators that we have today is assignment operators. Assignment operators like equals, uh, plus equal, minus equal, asterisk equal, not equal. These are all assignment operators. You assign a value to a variable. Okay? Just know about it for now, and we will take lots of examples in our real life uh, codes later in these lectures. But normally, you want as a basic level, you want to use it that much. Last operator that we are talking about today is comparison operators. Equal, not equal, greater than, less than, greater than or equal, less than or equal, all that. You remember when we used them equal, greater than, and less than with the Boolean operators? It's kind of similar thing. It will show you, uh, it will show you a true or false outcome. Let's take some examples here quickly. Brent 10 equals 10, Brent 10 equals 20, and Brent n equals 10.00. Let's see how is it. It will show you the first one true, of course, because 10 is equal 10. False for the second one, 10 does not equal 20. True for the third one, still 10 as integer equals 10 as float. All right? And so on. You can try with greater than, uh, less than, not equal. Okay, cool. Let's move on to a new topic, which is string formatting. String formatting is a very exciting topic. In Python, string formatting allows us to dynamically insert values into strings. String formatting has two methods. The old method of formatting uses placeholders to indicate where the values should be inserted. Let's explore the different placeholders and examples. I have placeholder S. The percent symbol is the placeholder S. That's string placeholder. S for string placeholder. Placeholder D, integer number placeholder. Placeholder F, float number placeholder. Let's take an example. I have here three variables, name, age, rank. Name Muhammad, age 36, rank 1. I will not give you my real age. That's not true. Okay, never mind. So let's try to print my name is plus, do you remember? Concatenation and the name variable. Will show you my name is Mohammed. I got the value of the variable name and concatenated it with a string. Okay? How can I use the placeholder here in this example? I can use the placeholder in two different ways, like this. Print my name is placeholder is string so that I tell the Python that the value that I am going to give you here is a string that you need to put it here in the placeholder for the string. The second line here, I did the same thing. The variable that I'm giving you here after the placeholder is a string. Put it here in the placeholder for the string. Let's run it. Perfect. Okay. Let's make it more longer than this. So I'm gonna say print my name is string placeholder and my age is integer placeholder, and I gave him the two variables, the name and the age. Do you see that? If you highlight on the name, it will show you it's a variable called name with the value of Muhammad, and the age is a variable with a value of 36. When you hit print, it will put the 36 in the integer placeholder and the name Muhammad into the string placeholder. One more example and we will move on. So my name is placeholder for string and my age is placeholder for integer and my rank is a placeholder for float point, and I give him name, age, rank, and hit run. It will place rank 1 in the float point and 36 in the age. name in the string placeholders. Let's move on to control floating point number. You see here, when I assign the rank in the placeholder F, it show you here 1.000000, 6 zeros. How can I control this amount of zeros in the right side of the floating point? Let's take an example. I have a variable with a value of 10, and I will print it as an integer and as a floating point and see how it looks like. Here, my number is 10, as it's an integer without any floating points. And the second one is my number is 10 with 6 zeros after the floating point. What if I want to make the floating point shorter? I don't want to get 6 zeros after the floating point. So what would I do? It's so simple. I'll come to the %f, and in between of the percent and f, I will add point 2. Point 2 means I want 2 zeros. I want 2 decimal numbers after the decimal point. Okay, let's see it. Oh no, that's correct. So my number is 10.00. It gives me only 2 decimal points. If I made 1 run, it will make only 1. 3 run, it will give you only 3. Okay? All right? Let's move on to another. Oh, that's a lot. Let's move on to truncate string. What if I want to truncate a string? What do you mean by truncate? I want to make a string short. Okay? Sometimes you want to truncate a long string to a specific length. Let's take an example. I have a long string that is hello Python wizards everywhere. And I'll print my message is, and I made a placeholder, and I want the long string to come to the S. But it's a long string. I want only five objects of this string. If you hit run, it will show only hello. Here, as we said, in the floating numbers, point 2 controls the number of zeros after the decimal points. Here, the point 5 before the S controls the number of letters that you want to use from a long string, and it's starting from the beginning from the start of the string. Okay, okay. All of that was the old formatting method in Python. So, and it provides a way to insert dynamic values into strings, making them more versatile and adaptable. In Python, string formatting has been enhanced with a new method that uses curly braces as placeholders, not the percent symbol. The new method provides more flexibility and readability. And let's explore the different placeholders and examples like we did in the old method. We have empty placeholder, that's the curly braces, will set the type automatically. If it is a string variable, it will set it to a string. A number, integer number, will set it as integer. Float will set it as float by default. Okay. And if you want to specify everything, so for the string, we'll open between the curly braces, we add colon S or colon D or colon F. Okay, let's take an example. Same example we had before. Name is Muhammad, age 36, rank is 1, and I would say Brent, my name is plus name. You remember this? This is concatenating. Okay, this is the concatenating. This is the very basic method. But now I will add that placeholder. And here, how can I do it? I write Brent, my name is placeholder and close double quotes dot format in the parentheses. I will just add the value I want or the string I want, Mohammed, and hit run. It will show you my name is Mohammed. So the syntax of this one is brackets dot format. Let's move on, and I can write it as this. Brent, my name is curly brackets, curly braces, dot format, and instead of giving the string, I will give the variable, and it will automatically set it to a string. Okay. Again, with the integer and the float, I will here say my name is empty brackets, my age is empty brackets, dot format, name and age, and will set automatically the type of formatting for name and age. Or I can type my name is in the curly braces, uh, colon S, colon D for age, colon F for float for the rank, and finally I put the dot notation and format and all the variables inside the format function. and hit run, it will show you the same thing. Again, if I want to control the floating point number here, I would simply add dot 2 like I did before, and it will give me only 2 decimal points. For truncating the string, again, it will show you the same thing as we did before. Let's show you an example here. Truncate string, hello Python wizards everywhere. And here I want only 5 letters from the long string. And here I want 13 letters of the long string. Hit run, it will give you hello. Message is hello, and message is hello Python. Clear? That's clear. Okay, let's move on. There is a new format method in version 3 of Python using um, let's see an example. Here is an example for the format in version 3.6 and moving on forward. Name is Muhammad, age 36. Brent, my name is curly braces name, my age is curly braces age. And I wrote you a comment here without if at the beginning. This one. It will print name. Let's hide this for now and run. It will treat everything here inside the double quotes as a string. So it printed my name is colon name in a curly braces and my age in curly braces. It didn't change anything. So in the new method, the only thing that you need to do is type if here, and you'll find the color is changing now. When you run the code, it will get the values and put them instead of the variables in the curly braces. My name is Muhammad and my name is 36. Let's put these back here and make a comparison between both. Run. Here you can see the difference when I added F and without adding F. Okay, so if you want to learn more about formatting, there is a huge website only talk about formatting, which is byformat.info. You will find lots of discussions about formatting. Okay, all right. What do we have more for this lecture in this training? Yeah, we have one more topic to discuss today, which is our last topic for today, is the concepts of indexing and slicing in Python. In Python, all data is treated as objects, and each object contains elements. These elements can be accessed using I want to okay, never mind. Okay, let's go on. In Python, all data is treated as objects, and each object contains elements. These elements can be accessed using their respective indices. Here are some key points to understand about indexing and slicing. All data is an object. In Python, everything is treated as an object, including strings, tuples, and lists. Elements and indices. Every element in an object has its own index, which represents its position within the object. Python uses zero-based indexing, which means the index starts from zero. You can access individual elements using square brackets and the index of the element. Let's take an example. I have a string which is I love Python, and I will print string. I will print from this string index number 0. In Python, indices start from 0. So the first letter here, first element here is 0 index. Second letter here is the space, is 1 index. L2, O3, V4, E5, and so on. So if I print the index number 0 from this variable, from the string variable, it will give me I, letter I. If I print the index number 9, it will show me T. Let's run it and see. Here, I and T. Okay? So, what if I want the first character from the end, not the beginning? It's so simple. I'll just add print string -1. It will print the first character from the end. -6, it will bring the sixth character from the end. Let's run. Uh, the last character from the end is N, and the sixth character from the end is P. Okay? That is a negative indices. Okay, clear? Clear. So let's move on. I'll talk about slicing. Slicing allows you to access multiple elements from a sequence, string, tuple, or a list. The slicing syntax is, as you can see here on the screen, start, colon, end not included, and start, colon, end, colon, steps. Where the start index is inclusive and the index is exclusive, you will see these. Let's put the string here and let's print some slicings and discuss them together here. First one, I will slice it from index number 8 to index number 11. It will show you YTH. I will slice it here from 3 to 5 is OV. If I don't put the start, it's not here. It will start from 0. If I don't put the end, and it will start from the start to the end. If I don't put the start or the end, it will give the full data. Okay? If I don't put the end and I put the step, it will give full data and so on. It's print as you see. The last two here, it will skip by 2. It will print the first letter I, then will skip these two and print L, and this skip this, print V, skip, and so on. I hope that you enjoyed watching this hands-on training, and I hope that you get the benefit of this uh, unit. And thanks for watching. And let's wrap up what we discussed today. We began with the basics of variables in Python. A variable is a container for sorting data. You can think of it as a labeled box that holds a value. We use variables to store and manipulate different types of data, such as numbers and text. Moving on, we explored the concepts of strings in Python. A string is a sequence of characters enclosed in a single quote or double quotes, and you can use a plus sign to concatenate strings together. And next, we discussed arithmetic operators, which allow us to perform mathematical calculations in Python. And these operators include addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. Understanding these operators is crucial for performing mathematical operations in your code. We also explored Boolean operators, which are used to evaluate conditions and determine the truth or falsehood of an expression. The three main Boolean operators in Python are and, or, and not. These operators help us make decisions and control the flow of our programs based on specific conditions. Additionally, we covered assignment operators, comparison operators, and string formatting techniques. Moreover, we delved into the concept of indexing and slicing in Python. Indexing refers to accessing individual elements of a sequence, such as strings, lists, or tuples, using their respective indices. Python uses zero-based indexing, which means the first element has an index of 0. Slicing allows us to extract multiple elements from a sequence by specifying the start and end indices along with an optional step value. Throughout this unit, we have covered a wide range of foundational concepts in Python programming. These concepts include variables, strings, arithmetic operators, Boolean operators, assignment operators, comparison operators, string formatting, indexing, and slicing. By understanding these fundamental concepts, you will have a solid foundation to build upon as you continue your journey in Python programming. Remember to practice and experiment with code to reinforce your understanding. Coding is all about hands on experience. I hope you found these practice examples helpful in your learning journey. If you have any further questions or need clarification on any topic, feel free to ask. And happy coding, and see you in the next lecture, in the next unit. Bye bye. Hello, Bison Wizards. This is Mo again, and welcome to the Bison Wizards for Beginners course. We will be diving into the exciting world of functions, modules, and data structures in Python. In this unit, we will talk about using built-in functions and modules, creating and calling functions, defining and importing modules, lists, tuples, and dictionaries, manipulating data structures, and working with nested data structures. Today we are going to start by exploring the power of built-in functions and modules in Python. These predefined functions and modules provide a wide range of capabilities that allow us to perform various tasks efficiently without having to write all the code ourselves. For example, we can use the print function to display output on the screen, as we have seen previously, making it easy to communicate with the user. Additionally, Python offers various built-in modules that extend the language functionality. One such module is the random module, which allows us to generate random numbers for games, simulations, or any scenario that requires randomness. We will see an example on the random module later in our hands-on training. By leveraging these built-in tools, we can save time and effort in our coding endeavors. Let's explain it more. In example 1, using the print function to display output. The print function is a built-in function in Python that allows us to display output on the screen. We can pass any value or expression as an argument to the print function, and it will be printed to the console. Like the famous example we have been encountering and practicing on in the previous lectures, print hello Python wizards will output the string hello Python wizard to the console. In example 2, importing and using the random module to generate random numbers. The random module in Python provides functions for generating random numbers. To use this module, we need to import it using the import statement. Once imported, we can access its functions by prefixing them with the module name. For example, import random, import the random module. Then we can use the randint function from the random module to generate a random integer within a specified range. The code random underscore number equals random dot notation randint from 1 to 10. This generates a random number between 1 and 10 and assigns it to the variable random underscore number. In the hands-on examples, we will talk about a variety of built-in functions and modules that can be used to perform different commands. So stay tuned. Next, we will delve into creating and calling functions. Functions are like small reusable programs that perform specific tasks. They are incredibly useful for organizing code and promoting code reusability. To create a function, we use the def keyword followed by the function name and parentheses that may contain parameters. Inside the function, we write the code that accomplishes the desired task. Let's consider an example. We can create a function called calculate underscore rectangle underscore area that takes in the length and width of a rectangle as parameters. Inside the function, we multiply the length by the width to compute the area. Finally, we use the return keyword to provide the calculated area as the result. By calling this function with different arguments, we can calculate the area of multiple rectangles efficiently. As in example 2, calling the function with different arguments to calculate the areas of multiple rectangles. After defining the calculate underscore rectangle underscore area function, we can call it with different arguments to calculate the area of multiple rectangles. For example, rectangle 1 underscore area equals calculate underscore rectangle underscore area 5 and 3. Call the function with the length set to 5 and width set to 3 as we predefined these parameters early, resulting in the area of 15 of the first rectangle being calculated and assigned to the variable rectangle 1 underscore area. Now let's explore the concept of modules in more detail. Modules are separate files containing Python code that can be imported into other programs. They allow us to organize our code across multiple files and facilitate code reuse. Consider an example where we create module called mathutils.py that contains utility functions for mathematical calculations. Inside this module, we define functions such as add underscore numbers and multiply underscore numbers. We can then import this module into our main program using the import statement and access and use these functions as needed, as in example 2, where I accessed the module called math underscore utils.by to perform the addition of 5 and 3 and store 8 or assign the value of 8 to the variable named result. This approach promotes code modularity and makes our code base more manageable and maintainable. In other words, in example 1, creating a module with utility functions for mathematical calculations, we created a module called math underscore utils.by. Inside this module, we define two utility functions, add numbers and multiply numbers. The add number function takes two parameters, a and b, and returns their sum, while the multiply number functions also take two parameters, a and b, and returns their product. But in example 2, importing the module and using the functions in our main program, to use the functions defined in mathutils module, we import the module using the import statement into our current code or program. After importing, we can access the functions by prefixing them with the module name. So that means I can call a function inside the module from a file that is stored in my computer other than my current file. For example, import math utils imports the math utils module. Then we can use the functions like result equals math utils dot add numbers 5 and 3 to call the add numbers function from the module mathutils and store the result in the variable result. I hope that example makes it clear, and we will see many examples later in our hands-on training. Moving on, let's discuss the fundamental data structures in Python: lists, tuples, and dictionaries. These data structures enable us to store and manipulate collections of data effectively. Lists are ordered collections enclosed in square brackets. They can hold items of any data type and are mutable, meaning we can change their contents at any time throughout the code. For instance, we can create a list of numbers and perform operations such as sorting them in ascending order or accessing a specific element by their index as presented in example 1. We will have lots of step-by-step examples together at the end of the lecture. In this example, we create a list called numbers that contains a sequence of numbers. Lists are defined by enclosing elements in square brackets. We can perform various operations on lists, such as sorting them in ascending order using the sorted function. For example, sorted underscore numbers equal sorted and between the parentheses, I included the variable numbers, and it creates a new list called sorted numbers with the elements from numbers sorted in ascending order. Additionally, we can access individual elements in a list using their index. Do you remember that the index starts from 0? Yeah. Okay. So numbers, closed brackets, square brackets of 0 retrieves the first element in the list, which is 5 in the old list and 1 in the new sorted list. Tuples are similar to lists, but they are enclosed in parentheses. Unlike lists, tuples are immutable. Their contents cannot be changed once defined. They are useful when we have a collection of items that should remain constant throughout the program. Dictionaries are unordered collections of key value pairs enclosed in curly braces. Each element in a dictionary consists of a unique key and its associated value. Dictionaries provide fast access to values based on their keys. For example, we can create a dictionary to store information about a student, including their name, age, and grade, as an example too. By using the appropriate keys, we can retrieve and update the values associated with those keys easily. By the way, you can try those codes on your VS Code workplace and use a print function to print the data stored inside the variables and see how it looks like and whether the code did the targeted outcome or not. Give it a try and let me know. Python provides a wide range of methods and operations to manipulate data structures efficiently. For instance, with lists, we can add elements using the append method or remove elements using the remove method. These methods allow us to dynamically update the contents of a list based on our requirements. In example 1, I have added a fourth element in the list by using append and removed the second element in the list by using remove. Dictionaries. Dictionaries offer methods to update or retrieve values associated with specific keys. By assigning a new value to a key, we can update the corresponding value as in example 2. We replaced the grade key A with another key B. This flexibility is crucial for managing data in various applications. Lastly, let's discuss working with nested data structures. These structures allow us to store complex data hierarchies by nesting one data structure within another. They play a crucial role in advanced data manipulation. For example, we can create a nested list to store information about multiple students and their grades. Each student details, such as name and grade, are stored as dictionary within the main list. This structure enables us to access and modify individual elements easily, as in example 1, where we store the grades of Emma and John individually in a nested structure. Nested structure makes the code shorter and more concise. Similarly, we can create a nested dictionary to represent hierarchical data. For instance, we can have a dictionary representing a student with another dictionary representing their personal details nested within it. This nested structure allows us to access and modify specific values using key-based lookups, as in example 2. Let's elaborate further. In example 1, we created a nested list called students to store information about multiple students and their grades. Each student's details are stored as a dictionary within the main list. This nested structure allows us to represent complex data hierarchies. For example, students is a variable which equals a list containing a dictionary for John's name and the grade A, and Emma's name and the grade B as another dictionary inside the list. That creates a list with two dictionaries, each representing a student and their grade. But in example 2, we have a dictionary called student that stores information about a student. The student's personal details, such as their age and grade, are stored as a nested dictionary within the main dictionary. To access values in a nested dictionary, we use multiple key lookups. For instance, student grade equals student, first key is details and the second key is grade, which retrieves the grade of the student by first accessing the nested dictionary using the key details and then accessing the value associated with the key grade within that nested dictionary. If it is not clear yet, don't worry. We will have lots of examples together soon in this unit. Now it's time to start practicing questions about variables and data types together. In the next lecture, you'll open your VS Code application and start working with me.
Imagine you have a recipe for making a delicious sandwich. The recipe tells you the steps to follow, such as adding ingredients, spreading sauces, and assembling everything. In programming, functions are a lot like recipes. They are blocks of code that perform specific tasks and can be used again and again. Let's go through some of the Python built-in functions one by one, and I'll try to explain them in a beginner-friendly manner with 1. Strip. The strip function removes any leading or trailing white space characters from a string. This can be useful when you want to clean up user input or remove unnecessary spaces. In this example, we have a string message that contains leading and trailing spaces. By calling strip on the message, we remove those spaces and obtain the trimmed version of the string, which is hello, world. The function is useful when dealing with user input or when working with strings that may have unnecessary white space. Restrip. The restrip function removes only the trailing white space characters from a string. It is useful when you specifically want to remove spaces or other characters from the right end of a string. In this example, the message string has trailing spaces. By using restrip, we remove those spaces from the right end of the string, resulting in hello, world. This function is useful when you only want to remove white space from the end of a string. Lstrip. The lstrip function removes only the leading white space characters from a string. It is useful when you specifically want to remove spaces or other characters from the left end of a string. Here, the message string has leading spaces. By applying lstrip, we remove those spaces from the left end of the string, resulting in hello, world. This function is useful when you want to eliminate white space from the beginning of a string. Title. The title function converts the first character of each word in a string to uppercase and the remaining characters to lowercase. It is often used to format strings as titles. In this example, the message string is in lowercase. By using title, we capitalize the first character of each word and convert the remaining characters to lowercase, resulting in the string hello, world. This function is useful when you want to convert a string to title case. Capitalize. The capitalize function converts the first character of a string to uppercase and leaves the rest of the characters unchanged. In the hello world you see, it will only change the letter H from small to capital and leave the rest of the sentence in small case. Sfill. The sfill function pads a numeric string with leading zeros, until it reaches a specified width. This can be helpful when working with numerical data that needs to be formatted consistently. Here, we have a string number containing the value 42. By using sfill, 5, we specify a width of 5 characters. Since the string has fewer than 5 characters, it gets padded with zeros at the beginning, resulting in the string 00042. This function is useful when you want to ensure a numeric string has a specific width, especially when dealing with formatting. Upper. The upper function converts all characters in a string to uppercase. It returns a new string with the modified formatting. In this example, the message string contains a mix of uppercase and lowercase characters. By applying upper, we convert all characters to uppercase, resulting in the string hello, world, all caps. This function is useful when you want to convert a string to uppercase. Lower. The lower function converts all characters in a string to lowercase. It returns a new string with the modified formatting. Just the opposite of the upper function. 9. Split. The split function splits a string into a list of substrings based on a specified delimiter. It returns a list of substrings. In this example, the message string contains a comma followed by a space as the delimiter. By using split, comma, we split the string into substrings whenever the delimiter is encountered. The resulting list is hello world. This function is useful when you want to break down a string into separate parts based on a specific pattern. Resplit. The resplit function splits a string into a list of substrings, starting from the right side, based on a specified delimiter. It returns a list of substrings. Here, the message string contains a comma followed by a space as the delimiter. By using resplit, 1, we split the string into substrings from the right side, considering the delimiter. The one argument specifies the maximum number of splits to perform, resulting in hello world. This function is useful when you want to split a string into parts starting from the right side. The split is the opposite of resplit, splits a string into a list of substrings, starting from the left side. Center. The center function centers a string within a specified width by padding it with a specified character. It returns a new string with the modified formatting. In this example, the message string is centered within a width of 10 characters, using dash as the padding character. The resulting string is hello. The function is useful when you want to center align a string within a given width. Count. The count function counts the number of occurrences of a substring within a string. It returns an integer representing the count. Here, we have the message string, and we want to count the occurrences of the letter O within it. By using count O, we find that there are 2 occurrences of O in the string. The function is useful when you need to determine the frequency of a particular substring within a larger string. Swap case. The swap case function converts uppercase characters to lowercase and lowercase characters to uppercase in a string. It returns a new string with the modified formatting. In this example, the message string contains a mix of uppercase and lowercase characters. By using swap case, we convert the uppercase characters to lowercase and vice versa. The resulting string is hello world. This function is useful when you want to swap the case of characters in a string. Starts with. The starts with function checks if a string starts with a specified substring. It returns true if the string starts with the given substring, otherwise, it returns false. Here, we want to check if the message string starts with the substring hello. By using starts with hello, we find that the string indeed starts with hello, and the function returns true. This function is useful when you need to verify the beginning of a string against a specific pattern. Ends with. The ends with function checks if a string ends with a specified substring. It returns true if the string ends with the given substring, otherwise, it returns false. In this example, we want to determine if the message string ends with the substring ! By using ends with ! we find that the string does indeed end with exclamation point, and the function returns true. This function is useful when you need to verify the end of a string against a specific pattern. Index, substring, start, end. The index function searches for a substring within a string and returns the lowest index of its occurrence. If the substring is not found, it raises a value error. Here, we want to find the lowest index of the substring O within the message string. By using index O, we find that the substring occurs at index 4 in the string. The function returns the index value. This function is useful when you need to find the position of a substring within a string. Note that as we said earlier, the first index is 0, so the H has an index 0, the E has index 1, and the O has index 4. Find, substring, start, end. The find function searches for a substring within a string and returns the lowest index of its occurrence. If the substring is not found, it returns -1. In this example, we want to find the lowest index of the substring O within the message string. By using find O, we find that the substring occurs at index 4 in the string. The function returns the index value. This function is similar to index, but instead of raising an error, it returns -1 if the substring is not found. Readjust, width, fill char. The readjust function right aligns a string within a specified width by padding it with a specified character. It returns a new string with the modified formatting. Here, the message string is right aligned within a width of 10 characters, using asterisk as the padding character. The resulting string is ******* hello. This function is useful when you want to align a string to the right within a given width. The adjust function does the opposite of readjust function, as in this example. In this example, the message string is left aligned within a width of 10 characters, using asterisk as the padding character. The resulting string is hello **********. This function is useful when you want to align a string to the left within a given width. Split lines. The split lines function splits a string at line breaks and returns a list of lines. Here, the message string contains a line break, \n, that separates two lines. By using split lines, we split the string at the line break and obtain a list of lines, hello, world. This function is useful when you need to split a multi-line string into separate lines. Expand tabs. The expand tabs function replaces tab characters in a string with a specified number of spaces. It returns a new string with the tabs expanded. In this example, the message string contains a tab character, \t. By using expand tabs, we replace the tab character with 4 spaces, resulting in the string, hello world. This function is useful when you want to control the spacing of tab characters in a string. Istitle. The istitle function checks if a string follows the title case formatting. It returns true if the string is in title case, otherwise, it returns false. Here, we want to check if the message string follows title case formatting. By using isTitle, we determine that the string is not in title case, and the function returns false. This function is useful when you need to verify if a string is formatted as a title. ispace. The ispace function checks if a string contains only with ispace characters. It returns true if the string consists solely of spaces, tabs, or new lines, and false otherwise. ilower. The ilower function checks if all characters in a string are lowercase. isidentifier. The isidentifier function checks if a string is a valid Python identifier. It returns true if the string can be used as a variable name, function name, or other identifier, and false otherwise. isalpha. The isalpha function checks if a string consists only of alphabetic characters, letters. isalnum. The isalnum function checks if a string consists only of alphanumeric characters, letters or digits. Replace. The replace function replaces all occurrences of a substring in a string with a new substring. You can also specify the maximum number of replacements to perform. Join. The join function concatenates the elements of an iterable, example, a list, into a single string, using a specified delimiter. All. The all function returns true if all elements in an iterable are true or if the iterable is empty. Otherwise, it returns false. Any. The any function returns true if at least one element in an iterable is true. If the iterable is empty, it returns false. Bin. The bin function converts an integer into a binary string prefixed with 0b. ID. The ID function returns a unique identifier, an integer, for an object. This identifier is often used to compare objects or track their references. Sum. The sum function returns the sum of all elements in an iterable, such as a list or tuple. Round. The round function rounds a number to a specified number of decimal places. Range. The range function generates a sequence of numbers within a specified range. It is commonly used in loops. Print. The print function displays the specified message or value on the screen. It is commonly used for outputting information in your Python programs. Abs. The abs function returns the absolute, positive, value of a number. It disregards the sign of the number. pow. The pow function raises a number to a specified power. Min. The min function returns the smallest element from a collection of values. It can be used with numbers, strings, or other comparable objects. 40. Max. The max function returns the largest element from a collection of values. It works similar to min, but returns the maximum value. 41. Slice. The slice function creates a slice object that represents a range of indices. It is commonly used for slicing sequences like strings or lists. 42. The map function applies a given function to each item in an iterable and returns an iterator with the results. In the example, we have a list of numbers 1, 2, 3, 4, 5. We use the map function along with a lambda function lambda xx***2 to square each number in the list. The map function returns an iterator, so we convert it to a list using the list function to see the squared numbers. The output 1, 4, 9, 16, 25 is the result of squaring each number in the original list. (43) The filter function applies a given function to each item in an iterable and returns an iterator with the items for which the function returns true. In the example, we have a list of numbers 1, 2, 3, 4, 5. We use the filter function along with a lambda function lambda xx%2 equals 0 to filter out only the even numbers from the list. The filter function returns an iterator, so we convert it to a list using the list function to see the filtered even numbers. The output 2, 4 is the result of filtering out the even numbers from the original list. (44) The reduce function applies a given function to the first two items in an iterable, then applies the function to the result in the next item, and so on, until a single value is obtained. In the example, we have a list of numbers 1, 2, 3, 4, 5. We use the reduce function from the functools module along with a lambda function lambda x, yx plus y to calculate the sum of all numbers in the list. The reduce function returns the final sum of all numbers, which is 15. (45) The enumerate function adds a counter to an iterable and returns an iterator of pairs containing the index and the value of each item. In the example, we have a list of fruits: apple, banana, orange. We use a for loop to iterate over the enumerated items using enumerate fruits. In each iteration, the index variable holds the index of the fruit, and the fruit variable holds the corresponding fruit value. The print statement displays the index and fruit value for each item. The output shows the index and fruit pairs for each item in the list. (46) The help function displays information about the usage and documentation of Python objects, such as functions, modules, or classes. In the example, we use help print to display the help information for the print function. The output will provide a detailed description of the print function, including its syntax, parameters, and usage examples. The help function is a useful tool when you need to understand how to use a specific Python object. (47) The reversed function returns a reverse iterator for an iterable, allowing you to iterate over the items in reverse order. In the example, we have a list of numbers 1, 2, 3, 4, 5. We use the reversed function to obtain a reverse iterator for the list. We then convert the reverse iterator to a list using the list function to see the numbers in reverse order. The output 5, 4, 3, 2, 1 is the result of iterating over the original list in reverse order. Now let's talk about the lambda you noticed in the sum of the examples above. The lambda keyword in Python is used to create anonymous functions. Anonymous functions are functions without a name, typically used for simple one-line expressions or as arguments to other functions. The general syntax of a lambda function is as follows: lambda space arguments colon expression. Here, arguments represents the input parameters for the function, and expression is the result of the function. The lambda function can take any number of arguments, separated by commas, but the expression must be a single line of code. Let's go through a few examples to illustrate the usage of lambda functions. Example 1. Adding two numbers using a lambda function. In this example, we define a lambda function add that takes two arguments x and y and returns their sum. We then call the lambda function with arguments 3, 4, and assign the result to the variable result. Finally, we print the result, which is 7. Example 2. Squaring a number using a lambda function. In this example, we define a lambda function square that takes a single argument x and returns its square. We call the lambda function with the argument 5 and assign the result to the variable result. The printed output is 25, which is the square of 5. Lambda functions are often used in conjunction with built-in functions like map, filter, and reduce to perform operations on iterable objects. Here's an example using map and a lambda function to double each element in a list. In this example, the lambda function lambda xx *2 is used with map to double each element in the numbers list. The result is a new list with the doubled values, which is then converted to a list using list and printed. Lambda functions provide a concise way to define small, inline functions in Python. They are especially useful in scenarios where a named function would be overkill or when a function is needed as a one-time use expression. However, it's important to note that lambda functions are limited to single expressions and cannot contain multiple statements or complex logic. Now that we have discussed many built-in functions, let's illustrate how to define and create functions giving examples and through explanation. In Python, you can define your own functions to encapsulate reusable blocks of code. Functions help organize code, promote reusability, and make it easier to maintain and modify your programs. Here's the general syntax for defining a function in Python. Let's go through an example to illustrate the process of defining and creating a function. Example 1. Adding two numbers using a function. In this example, we define a function called add_numbers that takes two parameters x and y. Inside the function body, we calculate the sum of x and y and store it in a variable called sum. We then use the return statement to send the result back to the caller. Outside the function, we call add_numbers with the arguments 3 and 4, and the returned value is assigned to the variable result. Finally, we print the result, which is 7. Functions can also have default parameter values, allowing you to call them with fewer arguments if desired. Example 2. Greeting a person with a default parameter. In this example, we define a function called greet that takes a parameter name. If no argument is provided when calling the function, it defaults to anonymous. Inside the function body, we construct a greeting message using an f-string and return it. We call greet without any arguments, and the default value is used. Then, we call greet with the argument Alice. In both cases, the respective greetings are returned and printed. Functions can also return multiple values using tuples. Example 3. Returning multiple values from a function. In this example, we define a function called calculate_stats that takes a list of numbers as the numbers parameter. Inside the function, we calculate the total sum, the count of numbers, and the average value. We return these values as a tuple. When calling the function and assigning the returned values, we use multiple variables to capture each value separately. Defining and using functions allows you to modularize your code, promote code reuse, and enhance the overall structure and readability of your programs. It's important to give meaningful names to functions and write clear and concise code within them. Now, we have done talking about functions and how to create and define them. Let's move on to modules and discuss some of the built-in modules and how to create our own modules as well. Python provides a rich collection of built-in modules that offer a wide range of functionalities. These modules are pre-installed with the Python interpreter and can be imported and used in your programs. Here are a few examples of commonly used built-in modules. The math module in Python provides a collection of mathematical functions and constants. By importing and using this module, you can perform various mathematical calculations. In the given example, we import the math module and use the constant pi to calculate the circumference of a circle. The math.pi constant represents the value of pi, and we multiply it by the radius to obtain the circumference. The random module allows you to work with random numbers and make random selections from sequences. In the example, we import the random module and use its functions. Random.randint, a, b, generates a random integer between a and b, inclusive. Random.choice, sequence, selects a random element from the given sequence. Random.shuffle sequence shuffles the elements of the sequence randomly. These functions are useful for scenarios where randomness is required, such as games or simulations. Three, the datetime module provides classes for working with dates, times, and time intervals. In the example, we import the datetime module. Datetime.date.today returns the current date as a date object. Datetime.datetime.now.time returns the current time as a time object. These functions allow you to retrieve and work with date and time information in your programs. Four, the OS module provides functions for interacting with the operating system. In the example, we import the OS module. os.getCode returns the current working directory. os.lister path returns a list of files and directories in the specified path. These functions are helpful for tasks such as file manipulation, directory management, and obtaining system-related information. Moving on to creating and using modules. Creating your own modules allows you to encapsulate related code and reuse it across multiple programs. Here's an exhaustive explanation of the steps involved. Step 1. Create a Python file with a.py extension. To create a module, you need to create a separate Python file. The file should have a.py extension. For example, my_module.py. Step 2. Define functions, classes, or other code in the module file. Inside the module file, my_module.py in this case, you can define functions, classes, variables, or any other code that you want to encapsulate. These definitions will become part of the module's namespace and can be accessed when the module is imported. In the given example, we define two functions, greet and add_numbers, and a variable, pi, inside the my_module.py file. The greet function takes a name as a parameter and returns a greeting message. The add_numbers function takes two numbers and returns their sum. The pi variable holds the value of pi. Step 3. Import the created module in your main program or another module. To use the functions and variables defined in your module, you need to import it into your main program or another module. In the example, main.py, we import the my_module using the import statement. Once imported, you can access the functions and variables from the module using the module name as a prefix. For example, my_module.add_numbers 3, 4 calls the add_numbers function from the my_module. Similarly, my_module.greet Alice calls the greet function with the argument Alice. Creating and using modules allows you to organize and modularize your code. It promotes reusability and makes your code more maintainable and readable. You can create as many modules as needed and import them into your programs to access their functionality. Now there is a question. Did you hear about packages? Let's make a comparison between packages and modules to elaborate further. In Python, modules and packages are both used to organize and structure code, but they serve different purposes. Let's discuss the difference between modules and packages. Modules. A module in Python is a file containing Python definitions, statements, and functions. It can include variables, functions, classes, and more. Modules provide a way to encapsulate related code into separate files, making the code more manageable and reusable. You can create your own modules or use built-in modules provided by Python or third-party libraries. Modules are imported and used in other modules or scripts using the import statement. Packages. A package in Python is a way to organize related modules into a directory hierarchy. It is essentially a collection of modules grouped together. Packages are created by organizing modules into directories and adding a special file called _init__.py in each directory. Packages help create a hierarchical structure to organize and manage modules that belong to the same domain or functionality. Packages can have sub-packages, forming a nested structure of directories and modules. Packages can be imported and used similarly to modules using the import statement. When importing a package, it implicitly executes the _init__.py file in the package directory. Here's an example to illustrate the difference between modules and packages. Suppose we have a project called my_project with the following structure. In this example, my_package is a package, and module1.py and module2.py are modules within that package. To use a module from a package, you would import it like this. To use a package, you would import it like this. In the first case, we directly import module 1 from the my_package package. In the second case, we import the entire my_package and then access module 2 within it using dot notation. Packages and modules work together to create a structured and modular code base. Packages provide a way to organize modules, while modules contain the actual code and functionality. It's important to note that packages and modules must adhere to naming conventions, such as using lowercase letters and underscores for both package and module names. Moving on to the final topic in our lecture today, which is lists, tuples, sets, and dictionaries. Let's discuss lists, tuples, sets, and dictionaries in Python, and the common functions used to manipulate and work with them. Lists. A list in Python is an ordered collection of items enclosed in square brackets. Lists can contain elements of different data types, such as integers, strings, or even other lists. You can access elements in a list using indexing, which starts at 0 for the first element. Slicing allows you to extract a portion of the list by specifying a start and end index. Lists are mutable, meaning you can modify their elements. Common list operations include appending, removing, sorting, and more. Example. In the provided example, we created a list called my_list containing integers and strings. We accessed elements using indexing. My_list 0 returns the first element, and slicing my_list 2:5 returns a sublist from the third to the fifth element. We then demonstrated list manipulation by appending an element, my_list.append, removing an element, my_list.remove, 2, and sorting the list in ascending order, my_list.sort. Tuples. A tuple in Python is an ordered collection of items enclosed in parentheses. Tuples are similar to lists, but they are immutable, meaning their elements cannot be modified once created. You can access elements in a tuple using indexing and slicing, similar to lists. Tuples are commonly used for grouping related data together and returning multiple values from functions. Example. In the provided example, we created a tuple called my_tuple containing integers and strings. We accessed elements using indexing and slicing, just like with lists. We also demonstrated tuple unpacking, where we assigned individual elements of the tuple to separate variables, x, y, z, *rest equals my_tuple. Sets. A set in Python is an unordered collection of unique elements enclosed in curly braces or created using the set function. Sets do not allow duplicate values, and they support mathematical set operations such as union, intersection, and difference. You can perform membership testing to check if an element exists in a set. Sets are useful for removing duplicates, performing set operations, and efficiently checking membership. Example. In the provided example, we created a set called my_set containing integers and strings. We performed membership testing using the IN operator. 1 in my_set returns true. We added an element to the set using the add method, my_set.add. Removed an element using the remove method, my_set.remove. 2. And computed the intersection of two sets using the intersection method. Dictionaries. A dictionary in Python is an unordered collection of key-value pairs enclosed in curly braces or created using the dict function. Each element in a dictionary is a key-value pair, where the key is unique and used to access the corresponding value. Dictionaries are useful for storing and retrieving data based on unique keys, similar to a real-world dictionary. You can access values in a dictionary using the associated key. Dictionaries are mutable, allowing you to modify, add, or remove key-value pairs. Example. In the provided example, we created a dictionary called my_dict with key-value pairs representing a person's name, age, and city. We accessed values using the associated keys. My_dict, name, returns Alice. We added a new key-value pair, my_dict, occupation, equals engineer, deleted a key-value pair using the del keyword, del my_dict, city, and retrieved all keys using the keys method. Lists, tuples, sets, and dictionaries are powerful data structures in Python, each serving different purposes and providing unique functionalities. Understanding when and how to use each of them can greatly enhance your ability to work with data effectively. Let's compare lists, tuples, sets, and dictionaries in terms of syntax, similarities, differences, and their use cases. One. Syntax. Lists, enclosed in square brackets, with elements separated by commas. Tuples, enclosed in parentheses, with elements separated by commas. Sets, enclosed in curly braces, with elements separated by commas. Dictionaries, enclosed in curly braces, with key-value pairs separated by colons, and pairs themselves separated by commas. Two. Similarities. All four data structures can store multiple elements in a single variable. They can store elements of different data types. Elements within them can be accessed using indexing and slicing. They support membership testing to check if an element exists. Iteration over elements is possible in all of them. They can be nested, meaning one can contain another. Three differences.
Welcome again, Python Wizards. Today we will delve into the fundamental concepts of control flow and loops in Python. These concepts are essential for building programs that can make decisions and repeat tasks, making them powerful tools in your coding toolbox. In this unit, we will cover conditional statements, if-else statement, looping statements such as for and while loops, and break and continue statement. Let's start with conditional statements, particularly the if-else statement. These statements allow your program to make decisions based on certain conditions. In real-world scenarios, you often encounter situations where different actions need to be taken depending on specific conditions. For example, consider a program that checks if a user's input meets a certain requirement and takes different actions accordingly. This is where if-else statements come into play. The syntax of if-else statement in Python is straightforward. We have the if keyword followed by a condition. If the condition evaluates to true, the code inside the if block will be executed. Otherwise, the code inside the else block will be executed. It's like asking your program, if this condition is true, do this. Otherwise, do that. The program follow branches based on the evaluation of the condition. If the door is closed, open it. If it is not closed, close it. That's it. Now let's look at an example to understand this better. Imagine we have a variable called age that represents a person's age. We can use an if-else statement to determine if the person is eligible to vote or not. By setting the condition to check if the age is greater than or equal to 18, we can guide the program to execute different actions based on whether the person is old enough to vote or not. If the condition is true, we print a message saying you are eligible to vote. Otherwise, we print a message saying, sorry, you are not old enough to vote. This way, the program dynamically responds to the age of the person, like you see here. It's really straightforward. Moving on, we have looping statements in Python, which allow your program to repeat a set of instructions multiple times. Looping is like having your program perform repetitive tasks without the need for manual intervention. It enables you to automate processes and save time and effort. There are two main types of loops in Python: for loops and while loops. The for loop is a common looping statement in Python. It iterates over an iterable object, such as a list or a string. For each iteration, the code inside the loop block will be executed. The loop automatically goes through each item in the iterable, executing the specified code for each item. It's like telling your program, for each item in this list, do something with it. Let's see an example for a for loop. Consider we have a list of fruits and we want to print each fruit on a new line. We can achieve this using a for loop. By iterating over the list of fruits, we can access each individual fruit and execute a print statement to display it. The loop will automatically go through each item in the list and execute the print statement, resulting in each fruit being printed on a separate line. The power of the for loop lies in its ability to handle repetitive tasks with ease. Another type of loops is while loop. Unlike the for loop that iterates over a collection, the while loop continues executing the code inside the loop block as long as the specified condition remains true. It's like saying, keep doing this until a specific condition is no longer true. Let's take a closer look at an example of a while loop. Suppose we have a variable called count initialized to be 0. We want to print the value of count and increment it by 1 until count reaches 5. Inside the loop block, we print the current value of count and then increment it. The loop will keep executing until the condition count less than 5 is no longer true. The while loop allows you to create dynamic and flexible loops that adapt to changing conditions. Sometimes we may want to modify the behavior of loops. That's where the break and continue statements come into play. They allow us to control the flow of execution within a loop and add more flexibility to our code. The break statement is used to exit a loop prematurely. It is often used when a certain condition is met, and we want to stop the loop immediately. Even if the original condition for looping is still true, think of it as an emergency exit that allows you to jump out of the loop when needed. The break statement helps you to break free from the loop's constraints and move on to the next part of your program. In our earlier example of printing fruits, let's say we want to stop the loop when we encounter the fruit banana. By using an if statement inside the loop to check if the current fruit is banana, we can use the break statement to terminate the loop. As soon as the condition fruit equals banana is met, the break statement will be executed and the loop will terminate immediately. This allows you to control the execution of the loop based on specific conditions. On the other hand, the continue statement is used to skip the remaining code in a loop and move to the next iteration. It's like saying, okay, I'm done with this iteration, let's skip to the next one. The continue statement allows you to skip certain iterations of the loop without completely exiting it. This can be useful when you want to skip a specific condition or perform certain actions only for certain iterations. For instance, if we want to skip printing the fruit banana in our previous example, we can use the continue statement by checking if the current fruit is banana, and using the continue statement, we can skip the remaining code inside the loop block for that iteration and move on to the next fruit. I will not exit the loop. I will not terminate the loop. I will just skip this iteration and continue to the next iteration. This way, the loop will continue, but the specific fruit that we want to exclude will be skipped. Okay? In summary, the break statement is used to terminate the loop completely, while the continue statement allows you to skip the remaining code for the current iteration only and move on to the next iteration. Both statements provide additional control over the flow of execution within loops and help you fine-tune the behavior of your program. To summarize, control flow and loops are crucial concepts in Python programming. Conditional statements, if, else, allow your program to make decisions based on conditions, enabling it to take different actions depending on specific situations. Looping statements, for and while, enable your program to repeat tasks, automating processes and saving time. Break and continue statements provide additional control over the flow of execution within loops, allowing you to terminate or skip iterations as needed. These tools empower you to write more dynamic and flexible code. Congratulations! You have learned the basics of control flow and loops in Python. These concepts are fundamental building blocks that will empower you to write more complex programs. Now it's time to practice using these concepts. In next lecture, as we used to do, we will open our VS Code application and start practicing together. Hello everyone. In today's practice examples, we will cover the following: if statement, for loop, while loop, break, continue, and pass, and nested flow control. The if statement allows us to perform different actions based on different conditions. In the provided example here, we take a user input. Let's write it. If statement. In this example, we take a user input here, input, that is the enter a number. We ask the user to enter a number and store it and convert it as integer, then store it in the variable number. Okay, and then we use the if, elif, and else statement to check its value. The first thing, if in the if statement, if the number is greater than 0, then we will print the number is positive. If the number, the other condition, elif, it means else if or elif, number is lower than 0, then I will print, I will use the function print, the number is negative. So is there any other condition? So it's either positive or negative, or the last condition is 0. So I would say in the last condition, else print the number is 0. Okay, so let's run and see how it looks like. So hit run button, and here it will ask you enter a number. Let's write 5, enter. Say the number is positive. Let's run again. Let's enter -5 and enter, the number is negative. Let's run one more time and enter 0 and enter, the number is 0. So we checked our code for the 3 different conditions and it is working. It's a good habit that you always check your code after you finish it. Okay, let's talk about a for loop. For for loop. Let's remove this, or let's add it in side treble codes to make it as a comment. Okay, so I can share it later with you. And now we'll talk about for loop. The for loop is used to iterate over a sequence or a range of values, as we mentioned earlier. Okay, so let's see an example for loop. Let me think of an example. Okay, here is an example. I have, excuse me, in this example, I have a list of numbers. So a list is in square brackets. The list consists 3, 5, 2, 7, 1, and I store this list in the numbers variable. And I will initiate another variable, which is sum, and will assign 0 to this variable. Then, using a for loop, it iterates this program iterates through each number of the list. In each iteration, the current number is added to the sum. So for NUM, this NUM is the number inside this list. For num in numbers, this list, sum plus equal num. So plus equal, the operator that we said we will talk about later, is I am assigning the right hand side to the left hand side, but I will do a addition operation as well in the same time. So every time I will add the value in the right hand side to the value that is stored previously in the variable in left hand side, and the new variable will be the new summation of the old value and the new assigned value. It will be cleared when we run the code. So what you need to know now is the plus equal sign. It accumulates the sum of the numbers. Okay? So in each iteration, the current number is added to the sum variable using the plus equal operator. Finally, outside the loop, outside of the for loop, the program prints the calculated sum. By executing the for loop for each element in the list, the program effectively adds up all the numbers in the list and provides the sum as the output. Okay, so let's run and see how it looks like. Here, the sum of the numbers is 18. Can we calculate here these numbers and see how much is it? 1, 3 plus 5 plus 2 plus 7 plus 1. This equals 3 and 7, 10, and 2 and 5, 15, and 2, 17, and 1, 18. So the output is 18, which is correct here. Okay, great. So there is something else with the for loop that I need to tell you about, which is I can use for loop with else, for loop and else statement. Okay, let's take a look on example for this one. I have a list of numbers And I will make a variable that is search underscore number to look for and assign a value of 5 into that variable. So in this example, we will iterate through the numbers in the list and print each number. The for loop iterates over each element in the numbers list. On each iteration, the current number is stored in the variable num. Inside the loop and an if statement, I have added an if statement here to check if the current number matches the search underscore number that I assigned 5 to it before or not. If it does match, the code inside the if statement block will be executed. So I will print number is found, number found. And then I said last time, a break will exit the loop. Okay? The break will exit the loop totally and go outside of the loop. So I will print number is found and then exit the loop using the break statement. But if the if condition is false, if the number does not equal to 5, the code continues to execute the remaining statement. We'll go here inside the loop and you say it will print the current number and it will print the current number like 3, 8, 2, 1, but not 5. If the loop completes if I iterated all the numbers and the loop completed without encountering a break statement, the else block is executed. I will execute the else block to say the associated the number is not found. So the else block is associated with the for loop, not the if statement. Okay, and here comes the importance of indentation. Do you notice the indentation of the if statement and the indentation of the for and else loop? For and else in the same indentation, and if statement has a different indentation. Okay, so the else block is associated with the for loop, not the if statement. It is executed when the loop completes normally without any break statement being encountered. In this example, it prints number not found. Okay, let's run this code and see how it looks like. See here, it printed 3, 8, 2, 5 and came to 5 and said the number is found. Let's remove the 5 from the list and change it with any other number. Okay, let's put 6 and run the code again. It will print everything 3, 8, 2, 6, 1 and finish the loop and went to the else statement and mentioned number not found. Okay, did you notice when I made if it was 5, it will not print until when. See the difference? It printed until 5 only and said the number is found, and the break statement terminated the loop, and the loop is finished. Okay, good. I hope it is clear, and I hope that the for statement and for else statement now are so easy to use. Now let's move to the other type of loops, which is while loop. While loop. The while loop is used to repeatedly execute a block of code as long as a certain condition is true. Let's take a look at example. Here in this example, we want to create a program that prints a countdown from a given number using a while loop. The program starts by initializing the count, a variable called count, to a specific number, in this case 5. It then enters a while loop, and that continues as long as the count is greater than 0. Inside this loop, we will print the current value of the variable count. Okay, and then it uh, decrements it by 1 using the minus equal operator. So the minus equal is just the opposite as plus equal. Minus equal decrements the value that is previously stored in the variable by the new value. This means that in each iteration, the value of count will be decreased by 1. Once the count variable becomes 0, the condition of the while loop becomes false. When the condition becomes false, the loop will exit. When I exit the loop, I'll find this print statement to say that the countdown is completed, to indicate that the countdown process has finished. Let's run and see. So here I started with 5. Second iteration will become 4. Third iteration become 3, 2, 1, and the last iteration is 0. And when it is 0, the condition is wrong. It's 0 is not greater than 0. So the while loop will terminate and go to the print function to print out countdown completed. I hope that's clear. And let's move to another example. Similar to the for loop, we can use else statement with while loop. So while loop with else statement. Let's take an example and discuss it. In this example, again, the while loop will continue as long as the count is greater than 0, and it will decrement by 1. Similar, just until here, it is similar to what we have discussed earlier here. But if the condition is true, the code inside the loop is executed. Okay? Otherwise, if the condition is false, I will enter. I said, otherwise, if the condition is false, the loop is exited and the program continues with the statements after the while loop. Okay? Inside the loop, we print the current value of count, which is then decremented by 1 using the count minus equal 1 statement. After decrementing the count, the loop will check here in this checkpoint. If count is still greater than 0, the loop continues to the next iteration. If count becomes 0, the loop condition becomes false and the loop is exited. But what if the loop completes without encountering a break statement? Like if I reach 0, the break statement will happen and I exit the loop. If that does not happen, the else block will is associated. The else block will be executed. So here again, the else block is associated with the while loop with the same indentation and not the if statement. Don't say, it's not always when you see if, then the else statement after if is with the if statement. No, it is not the case always. So you can see while and else together, or for and else. All right. So in this example, it will print countdown completed. Let's run this program and see how it is different than the previous one. The previous one, see here, 5, 4, 3, 2, 1, then countdown completed. The new one, well, 5, 4, 3, 2, 1, and there is no countdown completed because the break statement here in the if statement in the if block terminated the while loop and sent me outside here. Okay? All right. What else? Let's talk now about the break, continue, and pause statement. Break, continue, pause statement. The break statement is used to prematurely exit a loop, as we have seen in the previous examples with for loop and while loop. In the given example here, we iterate through the number in the list, this list, using a for loop. Inside the loop, an if statement is there. The if statement checks if the current number is odd by checking if the remainder of division, if dividing the number by 2 is not equal to 0. The even number, when you divide it by 2, there is no 0 for there is a 0 remainder. But the odd number, when you divide it by 2, there is a remainder of the division. It is not 0. So if the condition is true, the continue statement here immediately terminates the current iteration of the loop and moves to the next iteration without executing the remaining statements in the loop. In this case, it skips the print statement and proceeds to the next number in the list. But if the condition is false, indicating that the number is even, the print statement is executed and the number is printed. Okay. So let's run this code and see how it looks like here. Let's make this as 1, 2, 3 as as a comment. Then run this so we see only the result of this code. So here I checked 2 and it has no remainder. Checked 5. No, I checked 2. It has no remainder, so the condition is false. So I skipped printing the number by using continue, and I skipped this iteration and went back to check 5. When I divided 5 by 2, it gave me a remainder which is not equal 0. So I printed it, and so on. All right. Okay. What if we have multiple loops or conditions interrelated or nested? What if we have multiple loops or conditions interrelated or nested? Here comes the importance of nested loops and if statement. So let's take a look at an example of each one and discuss it. Start with nested if statement. Nested if statements allows us to have conditional statements within other conditional statements. In this example, we check the score against multiple conditions using if and elif statement. The outer if statement checks if the score is greater than or equal to 90. If it is correct, the code inside the if block is executed. So what is the code in the if block? It's a nested if statement here. So I will check if it is greater than or equal 95. 95 is still greater than 90. So I'll check if it is greater than 95. I'll print excellent, you achieved an A plus. But if not, if it is between 90 and 95, then I'll go to else, and the else statement will be executed. And I'll say, great, you achieved an A. If the outer statement, if the outer if statement is false, the score is not greater than or equal 90, I will move to the elif statement and check if it's greater than or equal 80, then I'll print good, you achieved a B. If not greater than or equal 80 and less than 80 but greater than or equal 70, I'll go to the next LF and print you achieved a C. If nothing of the previous conditions is correct, I will go to the final condition, that is else. I'll then print unfortunately you did not pass. Okay, let's run the code and see how it looks like. The run. You ask enter your score. I'll say 95 and prints great, excellent, you achieved an A plus. I run it again and said 90. Enter. Great, you achieved an A. Again 80. Great, good, you achieved a B. Again 70. You achieved a C. 60. Unfortunately, you did not pass. Okay, how about if I added 75? Good, you achieved a C. 75 is still, it is greater than 70, but it is less than 80. So I will I'll go through all of these steps. Is 75 greater than 90? No. So I will skip all this and go to the LF. Is 75 greater than 80? No. So I will skip this condition and move to the next one. Is 75 greater than 70? Yes. So I will execute this condition. All right. Hope it's clear. Let's move on to nested for loop. Let's make this here nested for loop. Nested for loops allows us to have one loop inside another loop. If in the provided example here, the outer for loop iterates through the rows, and while the inner loop iterates through the columns within each row. The outer for loop iterates through the range of values defined by the variable row, which is 5. On each iteration, the current value of I represents the row number. Inside the outer loop, we have an inner for loop, this one. The inner for loop iterates through the range of values defined by I plus 1. The I plus 1 part is used to control the number of asterisks, this asterisk, that is printed in each row. The first row will have 1 asterisk. The second row will have 2 asterisks. The third row will have 3 asterisks, and so on. Inside the inner loop, we print an asterisk on each iteration. Using the print function here. Print asterisk and end is an argument. Say at the end of the asterisk, just put nothing. So the end equal empty double quotes is an argument that is used to avoid printing a new line after each asterisk. After the inner loop completes, we use the print statement without any arguments to print a new line, creating a new row of asterisks. Then the outer loop continues to the next iteration, repeating the process until all rows have been printed. Let's run the code and see it here. The first iteration when I equals 1, so the number of rows is 5. 1, 2, 3, 4, 5. 5 rows. So I will iterate until I reach the maximum number of rows here, 5. Inside each row, I will iterate with the inner for loop, to print a number of asterisks based on the number of iterations. So iteration number 1 is printing 1 asterisk only. Iteration number 2, I am incrementing by 1, so it will print 2 asterisks. Iteration number 3 will print 3 asterisks, and so on. That's easy. Okay, so let's move on to nested while loops. Let's make it a comment here. Oh, this, put it here. Nested while loop. Nested while loops allows us to have one while loop inside another while loop. In this example, it's a big one. The outer while loop controls the replay functionality of the guessing game. So here's something more stimulating for you to focus on. So I play underscore game, which is yes, there is a string stored in the play underscore again, which is yes. Then I'll go to while. The outer while loop checks if the condition play underscore again dot lower means lowercase. You remember the functions that we talked last unit? Okay, I hope you do. So the lower checks if it's a lowercase or not. If it is yes, then as long as the condition is true, the code inside the loop is executed. This code will be executed. Otherwise, if the condition is false, the loop is exited and the program continues with the statements after the while loop. Inside the loop, we initialize the secret number to 7 and prompt the user to guess the number. The inner while loop keeps asking the user for a guess until the correct number is guessed. The loop condition is guess not equal secret underscore number. Meaning the while loop continues as long as the guess is not equal to the secret number. If the guess is incorrect, the code inside the loop is executed. It prints wrong guess, try again, and prompts the user for another guess. Once the correct number is guessed, the loop condition becomes false and the loop is exited and the code after the inner loop is executed. This one. I ask which that brings congratulatory message. Congratulations, you have guessed the number correctly. Then I'll ask again, do you want to play again? Yes or no. If they say yes, I will go back to the loop and check if if the answer I gave here, yes, I will continue the loop. The answer here is no, then I will not go to the loop and exit the game. Let's run and see how it looks like. Here, guess a number between 1 and 10. As I wrote here, guess the number between 1 and 10. Let's add 1 here, the console, 1, and enter. Wrong guess, try again, and ask you for the new number. 2, enter. Wrong guess, try again. 3, and so on, so on. Yes, here until the number is guessed correctly. Here, 7. guess the number equals 7. 7 because I added here a secret number 7. If I added another number, it will go until I achieve the correct secret number. Oh, it say here, congratulations, you guessed the number correctly, and ask you if you want to play again or not. If I answered yes, it will ask me again for the secret number. I'll say 7, and it will say congratulations, you guessed the number correctly, and ask you now, do you want to play again? I'll say no, and that will end the iterations of the while loop. With these examples, we demonstrated various scenarios of control flow and looping statements, showcasing the flexibility and power they provide for creating dynamic and interactive problems. I encourage you to go through the concept of the flow of execution, modify the code, and experiment with different inputs to gain a comprehensive understanding of how these concepts work in Python programming. I hope that you gained a better understanding about control flow and loops in Python. Remember that practice makes perfect, and see you in the next unit. And happy coding. Bye bye. Welcome to Unit 4 of our Python course, and where we will explore the essential concepts of debugging and error handling. These skills are crucial for every programmer as they help identify and resolve errors in code, ensuring smooth and error-free execution. In this unit, we will equip you with a range of techniques to effectively debug your Python code. Debugging is like being a detective, carefully examining your code to find and fix any mistakes. We will cover some tried and tested techniques to simplify this process and make it less daunting, even for first-time coders. So, we are going to talk about debugging techniques, common types of errors in Python, and handling of errors using try and except statement. Let's start by defining debugging. Debugging is the process of identifying and resolving errors in your code. There are some techniques to help you debug effectively. One of the fundamental aspects of debugging is using print statement strategically. By inserting print statements at critical points in your code, you can display the values of variables and track the flow of your program. This technique allows you to identify any discrepancies between expected and actual values, providing valuable insights into where the error might be occurring. Another powerful tool at your disposal is using a debugger. Python provides a built-in debugger called BDB, P for Peter, D for dog, B for book. which allows you to step through your code line by line and examine the values of variables at each stage. This interactive process helps you gain a deeper understanding of your code's execution flow and pinpoint any issues more effectively and efficiently. Divide and conquer is another useful strategy for debugging complex code bases. If you are dealing with a large code base or a particularly elusive bug, consider breaking your consider breaking down your code into smaller, manageable sections. By isolating specific sections, you can focus on finding the error within a smaller context, making it easier to identify and fix problems. Now imagine this. You are stuck with a persistent bug and you can't seem to find a way around it. Don't worry, sometimes all you need is a fresh perspective. This is where rubber duck debugging comes into play. Yes, you heard it right. Explaining your code line by line to a rubber duck or even a friend can surprisingly lead you to the solution. The process of articulating your code out loud often helps you notice the error you explain it as you explain your code, providing a unique way to uncover hidden bugs. Moving on, let's discuss the common types of errors you might encounter in Python. Errors in Python can be broadly categorized into three types. The first type is syntax error, which occurs when your code violates the rules of the Python language. The Python interpreter will raise a syntax error and provide a helpful error message indicating the issue. Similar to what we have seen in our previous lectures when we checked the errors and how descriptive it was. These errors are relatively straightforward to fix once you identify the offending line of code. Let's see an example. In this example, we have a syntax error. The closing parentheses in the print statement is missing. Python's interpreter detects this violation of the language rules and raises a syntax error. It indicates the line where the error occurred and provides a helpful error message. To fix this error, we simply need to add the missing closing parentheses like this, and then we can run our code again. The second type is runtime error, also known as exceptions. These errors occur during the execution of your code and can be caused by various factors, such as division by zero, accessing an unidentified variable or undefined variable, or performing unsupported operations. When a runtime error occurs, Python raises an exception, which can be caught and handled to prevent your program from crashing. For example, here we encounter a runtime error known as zero division error. It occurs when we attempt to divide a number by zero. Division by zero is mathematically undefined. So Python raises an exception to indicate the error. To handle this error gracefully, we can use a try and except block. Let's see how. By enclosing the division operation within a try block, we can catch the zero division error and execute the code in the except block. In this case, the program will display the error message, error division by zero occurred. We will talk about the try block in the coming slides. Lastly, we have logical errors, which are particularly tricky to identify, and they don't raise exceptions or cause a program to fail. Instead, logical errors produce incorrect results due to flawed logic in your code. These errors require careful examination of your code's logic and reasoning to identify and correct the issue. For instance, in this example, we encounter a logical error. The code attempts to calculate the average of a list of numbers, but there is a flaw in the logic. Instead of dividing the total sum of the numbers by the length of the list, the code subtracts 1 from the result. As a result, the calculated average will be incorrect. It will be the average minus 1. To fix this logical error, we need to modify the code as follows. We just remove the subtraction of 1 from the division operation to ensure that the average is calculated correctly. By the way, the len function here counts the number of objects or elements inside the list of numbers. Okay, so here the list of numbers include 5 numbers. So the len is abbreviation for length. Length of numbers is 5. So it will sum the number of the lists, which is 15, and divided by the length, which is 5, and give you the average, which is 3. Okay. Talking about handling errors using try and except statements, as a beginners, we just need to know or understand that Python provides a powerful mechanism to handle errors using try and except statements. The code within the try block is executed, and if an exception occurs, the code within the except block is executed. You may find it kind of similar to the if statement. If the condition is correct, do this, else do that. So if you try this, when you try this block is executed, if an exception occurs, then the except block is executed. This prevents the program from crashing and allows you to handle the exceptions gracefully. To handle exceptions effectively, Python provides a powerful mechanism using the try and except statements. The try block is where you place the code that might raise an exception. If an exception occurs within the try block, Python transfers control to the corresponding except block, which handles the exceptions gracefully. This prevents your program from abruptly crashing and allows you to respond to the error in a controlled manner. Do you remember the example we discussed on the runtime errors? In this example, we use a try and except block to handle the zero division error we encountered earlier. The code within the try block attempts to perform a division operation, which may raise an exception. If an exception occurs, Python transfers control to the except block, where we handle the error gracefully. By executing the code within the except block, we can display a custom error message to the user, informing them that a division by zero occurred. What if I have multiple errors that may happen and I need to do multiple exceptions? You can handle multiple exceptions by including multiple except blocks, each targeting a specific exception type. Python will match the exception raised with the appropriate except block and execute the corresponding code. Additionally, you can include a generic except block at the end to catch any remaining exceptions that were not explicitly handled. Let's take an example. In this example, we demonstrate how to handle multiple exceptions using multiple except blocks. The code within the try block accepts user input and attempts to perform a division operation. We anticipate two specific exceptions. Value error, if the user enters an invalid input. Example, a non-numeric value, such as he added donkey or ABC or anything other than numbers. And zero division error, if the user enters zero as the input. By including separate except blocks for each exception type, we can handle each error situation differently. The code within each except block will execute if the corresponding exception is raised. Additionally, we have a generic except block at the end of the code to catch any other unanticipated exceptions and handle them accordingly. So, the important takeaways from this unit is debugging and error handling are crucial skills for every programmer. Remember the key techniques for effective debugging, common types of errors, and how to handle exceptions using try and except statements. With practice, you will become proficient at identifying and fixing errors in your code. Thank you for your attention. I hope you find this presentation on debugging and error handling informative and engaging. Now it's time to roll up our sleeves and dive into the world of debugging. Happy coding, and remember to always keep an eye out for those pesky bugs. Remember to analyze each error carefully, use the appropriate debugging technique, and handle exceptions gracefully to ensure robust and error-free code. Congratulations, you have learned the basics of debugging and error handling in Python. These concepts are fundamental building blocks that will empower you to write more complex programs with minimal coding errors. And now it's time to practice using these concepts. I will leave it this time for you to practice on your own the examples that we discussed in this lecture. So open your VS Code application and start trying what you learned in this unit, and ask me any question you have, and I'll be there answering your questions and guiding you throughout your learning journey. Welcome to Unit 5 of the Python Wizards course, where we dive into the exciting world of object-oriented programming, OOP, in Python. In this unit, we will cover three main topics: understanding objects and classes, creating and using objects and classes, and exploring inheritance and polymorphism. Let's begin by understanding what objects and classes are. Objects are instances of classes that hold data and perform actions. Think of them as real-world entities. Classes, on the other hand, serve as blueprints or templates for creating these objects. They define their attributes, characteristics, and methods, actions. For instance, let's talk about the example of cars. A car is a class that could have attributes like color, brand, model, and fuel type. Its methods might include starting the engine, accelerating, braking, and turning. Or an animal, which is a class with attributes name and age, and behaviors like eat and sleep. Suppose we want to represent cars in our program. We will create a car class with attributes such as color, brand, model, and fuel type. We will also define methods like starting the engine, accelerating, braking, and turning. In this example, we define the car class with attributes, color, brand, model, field type. Using the init, short name for initialization method, which is a special method called when a new object is created. The methods start the engine, accelerate, brake, turn, define the actions a car can perform. We create a car object, my underscore car, by calling the car class and providing the necessary arguments. We can then access the attributes and call the methods using dot notation. Like we can use object name dot attribute and object name dot method. So the steps we followed can be outlined as 1. We define a class called car using the class keyword. It serves as a blueprint for creating car objects. 2. Inside the class, we define the init initialization method, which is a special method that initializes the car object with the provided attributes, color, brand, model, field type. The self parameter refers to the instance of the object being created. 3. Next, we define methods such as start engine, accelerate, brake, and turn, which represent the actions that a car can perform. 4. To create a car object, we call the car class and provide the required arguments for the attributes defined in the initialization method. This creates a specific instance of a car with its unique set of attributes values. 5. We can access the attributes of the car object using dot notation, object name dot attribute. For example, my underscore car dot color gives us the color of the car. 6. We can also call the methods of the car object using dot notation with parentheses, like object underscore name dot method. For instance, my underscore car dot start underscore engine starts the engine of the car. I hope you followed up with me on this code and the comments that I wrote for you in the code snippet on the screen. Now that we understand the basics, let's move on to creating and using objects and classes. It involves 3 simple steps: defining a class, creating objects from that class, and accessing their attributes and methods. We will walk you through some code examples to make it easier for you to grasp that concept. To demonstrate, let's create a simple class called dog. The class has attributes like name and age, as well as a method called bark. Creating and using objects is simple. We create objects by excuse me. We create objects by instantiating classes using the class name followed by parentheses. We can then access the object's attributes and call its methods using dot notation. Let's take a look at an example. We create an object of the dog class named dog1. We can access its attributes, name and age, and call its method bark using dot notation. In this example, let's snippet at the top. We define a class called dog. The dog class has two methods. The initiator or the constructor initialization and the bark method. The constructor or initialization in init is a special method that gets called when we create a new object from the class. It initializes the object with the provided name and age values. The bark method is a simple method that prints woof when called. To create an object from the dog class, we use the class name followed by parentheses. We pass the arguments body and to the constructor, which assigns them to the name and age attributes of the object. So our dog, his name is Buddy, and his age is 2, and he bark and say woof. We can then access the attributes and call the methods of the object using dot notation. For example, in the bottom snippet, we print the name and age attributes of the dog1 object. We also call the bark method of the dog1 object, which prints woof to the console. Let's create a rectangle class that calculates the area of rectangles. We will demonstrate how to create objects, class access their attributes, and call their methods. In this example, we define the rectangle class as attributes with attributes length and width, and a method area to calculate the area of the rectangle. We create two rectangle objects, rectangle 1 and rectangle 2, with different lengths and widths. We can then access the attributes using dot notation, object name dot attribute, and call the method using dot notation with parentheses, object name dot method parentheses. Again, in order to create a rectangle class that calculates the area of rectangles, the following steps were followed. First, we defined a class called rectangle using the class keyword. This class represents rectangles and provides methods to work with them. Second, inside the class we defined the init method. that takes in two arguments, length and width. These arguments are used to initialize the attributes of the rectangle object. Thirdly, we also defined a method called area that calculates the area of the rectangle by multiplying its length and width attributes. Fourth, to create a rectangle object, we called the rectangle class and provided the required arguments for the length and width attributes. This creates a specific instance of a rectangle with its unique length and width values. We can access the attributes of the rectangle object using dot notation, object name dot attribute. As we said, for example, the rectangle 1 dot length gives us the length of the rectangle number 1. Finally, we can call the area method of rectangle object using dot notation with parentheses object underscore name dot method parentheses. For instance, rectangle 1 dot area parentheses calculates and returns the area of rectangle 1. If it's not clear yet, we will have practice on examples in the coming lecture. Next up is inheritance and polymorphism. Inheritance allows us to create new classes, subclasses, based on existing classes, superclasses, inheriting their attributes and methods. Or you can think of it like father like son. The father is the superclass and his sons or daughters are the subclasses, so they inherit their attributes from their father. Polymorphism, on the other hand, enables objects to take on different forms based on the context. We will demonstrate this through an example involving animals. To illustrate inheritance, we create a subclass called German Shepherd, inheriting from the dog class. The German Shepherd class has its own additional method called guard. Objects of the subclass can access both the inherited and new methods. In this example, we demonstrate inheritance and polymorphism. We create a subclass called German Shepherd that inherits from the dog class. The German Shepherd class has an additional method called guard that is specific to German Shepherd dogs. To create an object of the German Shepherd class, we use the class name followed by parentheses. Then we pass the arguments max and 3 to the constructor of the German Shepherd class to add the name and age. Since the German Shepherd class inherits from the dog class, objects of the German Shepherd class have access to the bark method from the dog class. This is why calling German Shepherd .bark prints woof. Additionally, objects of the German Shepherd class have access to their own unique method calling guard. Calling German Shepherd.guard parentheses Brents, I am guarding the house. This could be an example of polymorphism as well, as we can treat the German underscore Shepherd object as an object of the dog class, its parent class, and call its inherited method bark as well as its own unique method guard. Polymorphism allows us to treat different objects as if they belong to a common parent class. We demonstrate this with the cat and lion classes, both having a sound method. The function make underscore sound can accept either a cat or a lion object and call their respective methods. In this example, we have two classes, cat and lion. Both classes have a method called sound. The cat class has a sound method that prints meow, representing the sound of a cat that the cat makes. The lion class also has a sound method, but it prints roar to represent the sound of a lion. We can define a function called make underscore sound that takes an animal parameter. Inside the function, we call the sound method of the animal object. Then we create two objects, cat and lion. The cat object is an instance of the cat class, and the lion object is an instance of the lion class. When we call make underscore sound cat in the parentheses, the sound method of the cat object is executed and it prints meow to the console. Similarly, when we call the make underscore sound and lion inside the parentheses, the sound method of the lion object is executed and it prints roar to the console. This demonstrates polymorphism, where objects of different classes, cat and lion, are treated as objects of a common parent class, not explicitly defined in this example, but they both have a sound method. The make underscore sound function can accept either a cat or a lion object and call their respective sound methods, producing different sounds based on the object type. Polymorphism allows us to write flexible and reusable code, as we can use a single function, make underscore sound, to perform different actions depending on the type of object passed as an argument for this function. Let's create another example of an animal class and two subclasses, dog and cat. The subclasses will inherit the attributes and methods from the animal superclass, and we will demonstrate polymorphism by calling the speak method on different objects. In this example, We define the animal class with a speak method. We then create two subclasses, dog and cat, which inherit from the animal class and override the speak method with their own implementations. We create a list of animals containing a dog object and a cat object. By iterating over the list and calling the speak method on each object, we can observe polymorphism in action. The dog object will return woof, and the cat object will return meow. In other words, we did the following steps. We defined a class called animal using the class keyword. This class serves as a base class or superclass for other animal-related classes. Inside the animal class, we defined a method called speak with a pass statement. This method does not have any implementation in the animal class itself. We created two subclasses, dog and cat, which inherit from the animal class by including the superclass name in parentheses when defining the subclass. Like we see, class dog, open parentheses, animal. We inherited the adjective of animal, the superior class of animal, to a dog as a subclass of this animal big group. In the dog subclass, we override the speak method with a specific implementation for dogs, which returns the string woof. In the cat subclass, we override the speak method with a specific implementation for cats, which returns the string meow. We created a list called animals and add instance of the dog and cat classes to it. Using a loop, we iterate over the animals list and call the speak method on each object. Since each object is either a dog or a cat, the overridden speak method of the respective subclass is invoked, resulting in the corresponding sound being printed. I hope these detailed examples help you understand objects, classes, inheritance, and polymorphism better. If it doesn't, we will have examples later on, our hands-on examples. To summarize, we have covered the fundamentals of OOP, objects, classes, creating and using them, and inheritance and polymorphism. Now it's time for you to put your knowledge into practice. I encourage you to create your own classes and objects. Experiment with inheritance and explore more advanced concepts like encapsulation and abstractions. I will leave that for you to Google them and know about encapsulation and abstraction. And I need you to comment in the lecture below how and what did you come up with about encapsulation and abstraction. Remember, the key to mastering OOP is practice and exploration. Congratulations! You have learned the basics of object-oriented programming in Python. These concepts are fundamental building blocks that will empower you to write a more complex program with more object-oriented look. Now it's time to practice using these concepts. We'll meet you in the next lecture. Open your VS Code application and we'll work together in some examples. Hello everyone. Today we have an exciting code example to explore. It's a Python program that showcases object-oriented programming concepts using animals as our theme. Let's dive into the code and understand it step by step. First, we start by defining a class called animal. And in this class, we have a special method called underscore underscore init underscore underscore, which serves as the constructor of the class of the function. It takes in parameters such as name and age to initialize the object. Someone will ask me, what is self? And I forget to mention it in the previous lecture. So the self keyword represents the instance of the object itself. Okay, so it represents the instance of the object itself. Then after that, we will move to introduce method or a function inside the animal class, and this method uses the print statement to display uh, a message introducing the animal. It includes the name and age of the animal. Let's see how we will define that here. This is the function that introduces the animal, and I have formatted the string inside the print function with the new string formatting method that we talked about in the previous lectures. Okay, then after we finish the class of animal, we will make another class for our first animal, that is a lion. So we'll make another class for a lion which inherits the characteristics or inherits the class of the lion, that inherits the class of the animal, sorry, and the animal class, and it has its own constructor here with the name, age, and main color. And it's there is an additional parameter like here the main color. We use a super here. We use a super function to call the constructor of the main parent class, that is the animal class. Okay, and so and so that super function calls a constructor of the parent class and set the name and age attributes. So the name and age attributes here will be driven from the parent class, the animal class. Then we set the main color here, attribute specific to the lion. Similarly, we have the introduce method in the lion class that overrides the introduce method of the parent class to provide a customized introduction for the lion. The message includes the lion's name, the lion's age, and the main color. Okay. So is that all we have in the code? No, not yet. We have another class for an elephant. So let's, as similar to the main class and the lions class, we will develop a elephant class. Just the same. In the elephant class, it also inherits from the animal class and has its own constructor, uh, underscore underscore init underscore underscore self name age trunk length parameters. Again, we will use the super function to call the parent class constructor and set the name and age attributes. So I will inherit the attributes of the parent class to the name and age. Then we set the trunk length attribute that is specific to the elephant. Just like the previous classes, the elephant class has its own introduce function or method. It provides the introduce. It overrides the introduce method of the parent class to provide a specialized introduction for the elephant. The message includes the elephant name, the elephant age, and the trunk length. After we have after we have defined the parent class and the subclasses, the lion class and elephant class, we need to make a zoo introduction function. Here we define a zoo introduction function that takes an animal object as a parameter and calls the introduce method on that object. So if I added here for the animal, I added the elephant, it will go to the elephant class and call the introduce function for the elephant. But if I went to the lion it will go back to the lion class and call the introduce function for the lion. Okay, so this function allows us to introduce any animal object regardless of its specific class. So if I added a giraffe or anything else, it will drive the introduce from the parent class. It will drive the introduce here from the parent class. So now that we have defined our classes, and functions. Let's put them into action. We create a line object named Simba with an age of 5 and a golden mane color. We also will create an elephant object named Dumbo with an age of 10 and trunk length of 2.5. To see their introductions, we need to call the zoo introduction function and pass lion and elephant objects one by one, and this function internally calls the introduce method on each object, printing their respective introductions. Let's add one more uh, variable here, giraffe equals uh, animal or giraffe, and the name of the giraffe, Lola, and the age is 7. Because I don't have a giraffe, I'll use animal. Lola giraffe. The age is 7. Then I'll call it through the zoo introduction and add here giraffe. And we'll say run the code. See? The first one called the lion class, the lion subclass, and printed my name is Simba. I am 5 years old and my main color is golden. The second line called the elephant class and said, my name is Dumbo and I am 10 years old and my trunk length is 2.5. But the third variable, when I called the giraffe, I don't have a subclass for giraffe, so it went directly to the parent class animal and used the introduce method from the animal class, from the parent class, and mention my name is Lola Giraffe and I am 7 years old. I hope that this comprehensive example cleared the idea of inheritance and object-oriented classes and objects, polymorphism, all we have talked about in our previous lecture. But anyway, if you have any questions regarding that or any other lecture, feel free to ask me anytime, and I'll be there guiding you through your learning journey. Goodbye. Hello, Python wizards, to our final unit in this course, and I hope you enjoyed it while learning the magic of coding with Python. Let's combine all what you learned from defining functions, if statements, loops, and object-oriented concepts. We have created a simple calculator program that allows you to perform basic arithmetic operations. This is a simple example to demonstrate the concepts of functions, conditionals, loops, and user input output in Python. It allows users to perform basic arithmetic calculations and demonstrates the flow of control in the program. Let's walk through how it works, and we will also go through the concepts that you learned so far as a final review. First, we started with a comment. As you can see in the screen on the screen, we started with a comment denoted by hashtag symbol mentioning what is the code about. Comments are ignored by the Python interpreter and are used to provide explanations or documentation for the code. Then we will move to defining functions. We will define four functions: addition, add, subtract, multiply, and divide. Each function takes two numbers as input and performs the respective operation, returning the result. This add function takes two parameters x and y, and inside the function it adds x and y together and returns the result. Similar to the add function, these lines define a subtraction or a subtract function that takes two parameters and subtract them, takes x and y, and inside the function it subtracts x and y and returns the result. In addition, this function multiply takes two parameters, x and y, and returns their multiplication. While this function divide takes two parameters, x and y, and it checks if y is not 0, if y is not equal to 0, it will return x divided by y. But if y is equal to 0, it will go to the else and return print function error division by 0. Okay. After defining the four functions, we will start interacting with the end user with greeting them first by using a print function. We'll say welcome to the symbol calculator, for example. We then will use a while loop that will continue indefinitely until a break statement is encountered. The condition true ensures that the loop will always run indefinitely. After that, we will use a print function to display the menu options for the user to select an operation. For example, we will say print, please select an operation. And I will give him the menu option with the print functions. 1 for add, 2 for subtract, 3 for multiply, 4 divide, 5 exit. You can use another way to write all these print functions using the escape escape operations that we talked about, the \n, and do one long print function including all of that. You can try it. So after giving the instruction to the user using the print functions, the input function here is used to prompt the user for input. Now it's time to ask the user for an input. I'm asking the user enter your choice from 1 to 5. And the entered value is stored in the choice variable. Before moving further in calculations, we will check the user input first. This is an if. How to check the user input? Right away, yes, it's an if statement. We will use this if statement to check if the value of a choice is equal to 5. So I will say thank you for using the symbol calculator and goodbye. And I'll break the while loop and continue. Okay. So I use the break statement here to check so that when the end user enter 5, which is exit, the break function, the if statement, checks if it is 5, then it is gonna end the while loop and escape from the true condition above. All right. Okay. So, but if not equal to 5, and the user selected any number from 1 to 4, if that is the case, these four these lines prompt the user to enter two numbers, number 1 and number 2. The input function will take the two numbers and convert them to a floating point number, and then store them in number 1 and number 2. After I take the two numbers, when the user inputs their numbers, I will use another if statement, if, elif, and else statement to check the multiple conditions that I mentioned above. Is it 1 or 2 or 3 or 4? So that I can go for the condition that suits the end user input. Here we go. I make an if, elif, else statements that check the value of a choice to determine which operation to perform. If the choice is 1, then it calls the addition function that I defined earlier here. So if it is 1, I will call this function to make the addition and return the result and store it in the result variable. If the choice is not 1, I will go to the second elif condition and check if it is 2 or not, and so on. Check every condition until if none of these conditions is valid, I will go to the else and to the else statement and print invalid choice. Please try again. What if the end user by mistake hit number 6? That's a choice that is not available in the list of choices here. In that case, the else statement here will show invalid choice. Please try again. It will make the end user realize that he entered an invalid choice so that they can try another valid choice. Okay? Okay. What if the user inputs a number other than the numbers in the instructions? We said already the else will say that's an invalid choice. Please try again. That's the end of the code. So let's uh, run it and see how it looks like. Run. Here, the program asks you, welcome to Symbol Calculator. Please select an operation. 1, 2, 3, 4, 5. If I enter 1 and say enter, it will ask me enter the first number. I will say 5. enter the second number. I will say again 5. Then it will show you the result is 10. And the while loop will reiterate again and ask you the same questions. Please select an operation. 1, 2, 3, 4, 5. Let's check 2 now and check the subtraction. Now 5 and the other number 5, then the result is 0. Let's move on to check the multiply. 3. 5 into 5, the result is 25. Moving on to divide. 4, enter 5 and 5, the result is 1. Let's before trying the 5 exit, I will put 6 as I said and enter. It will ask you for the first number 5 and the second number 5, and it will say invalid choice, please try again. And go back to iteration. Enter now, I will enter now 5 and hit enter. Well, that exits the loop with the break statement here and say thank you for using the simple calculator. Goodbye. That is the end of our lecture today. End of the lecture. And I hope that you enjoyed so far, and see you in the second final exam, where the second final project that we will develop a game together, a simple game that is XO, and keep practice and happy coding. Goodbye.